Welcome back, everyone. This is Mike Gibbs, and we are here for day 2 of the Go Cloud Careers completely free Azure Solution Architect Expert Bootcamp. And in these next 2 weeks, we'll prepare you for the Azure Solutions Architect Expert exam, the AZ-305. If you've just joined us, remember in the first week of this 2-week session, what we're doing is we're going over the fundamentals of cloud computing. We're going over Azure fundamentals, and we're going to dive under the hood of various technologies. I've interviewed about 5,000 to 6,000 people over the years and well over 1,000 AWS and Azure certified people. And when you ask questions, most people don't understand the underlying technology. And here's the sad reality. If you don't understand the technology, what you're working with, you can't design it. And sadly, as much as I love hands-on experience, you can't learn how the technology works by building it. You can learn how to build it by building it. So we're going to focus a little more on the underlying technology. So we are here for day 2. We're going to not only cover the Azure things, but we're going to maybe get under the hood. Maybe we bring you to our data center. Maybe we show you some other things. So real excited about day 2. If you have a chance, invite a friend. It takes a lot to put on training like this. There's a team of people in the back end that are working on things. So invite some others. I'd love as many people to benefit as possible from this free training. Before we begin, I want to call your attention to a few things. I'd love you all to get hands-on and do some hands-on things, but we really need all 2 weeks to really give you guys some knowledge. So please get the free Azure lab demonstrations. You can do these labs on your own time. They're completely free. All you need to do is go sign up for them. So go sign up for these labs. Also wanted to let you know that once per week on this channel, we actually run a free question and answer session that's dedicated towards your career. So come and bring your questions. We typically do them 1 day per week. We're not doing this week, obviously, because of the webinar, but we do it every week. So if you want to know how to get your goals and you've got some questions about your career, we do it completely free once a week on this channel. And on Thursday this week, and actually Thursday every week, we have a how to become a cloud architect, how to get your first cloud architect job or solution architect webinar. It's completely free. It'll be on Zoom. Why do I love Zoom so much? Because we can all get there and be together. We'll go over the role, what we do, all the skills that you need, how to get hired when you don't have experience, how to skip HR so you don't get auto-rejected, and everything that matters. It's all free, and it'll be on Zoom, and then we'll answer your career questions. It's on Thursday, like every Thursday. So sign up. And of course, in the description of this video, there are so many free things. Free documents on how to win an interview. My team can also pop these kind of things in the chat box for you. Free things to know if you want to become a cloud architect or an AI architect or an enterprise architect. There's so many free resources. So get them, grab them. They're all free. We love training people around here. So I want to know that you're awake, alert, and oriented before we begin. So give me a hashtag, Azure Solutions Architect Expert. And when I know that and I see those hashtags, I know that you are awake. I see some people in Sacramento. I see Michigan. I know there's some people in Cameroon in addition to Eddie that's over there. Glasgow, I haven't been there in a little while, though I always liked it over there. It's nice to see. Ashford, UK. I haven't been there in a little while. I haven't been to Argentina in a little while, but boy, I always loved it over there. So there's there. And if anybody missed yesterday, it's okay. Each day is going to stand alone. Go back and watch the other day. It doesn't matter. Today, we're going to talk about RAID and compute. Yesterday, we talked about some storage and some basic networking things. So it doesn't matter. You can go back. We're going to leave these videos up on YouTube. Share it with a friend so that they can benefit from this free training as well. So super excited. If you're not a subscriber, maybe subscribe and hit the bell to be notified of new videos for your career, assuming you like what we're doing here today, and hit the like button if you're having a good time. It'll signal the algorithm to send more people to this so that we can benefit them with this free training. Now I'm seeing some people in Jamaica, one of my favorite places in the world. Always loved it in Montego Bay over there. Spent some time in Kingston as well. Malta, that's fantastic. That's one place I actually haven't been. But one place I actually need to get to. So we're going to begin now, and we're going to talk about RAID. So you may notice that many of the things we're talking about when we talk about cloud computing are very old. In fact, there's nothing new about cloud computing. The first cloud I worked on was in 1993. It was the frame relay cloud. And then around 1996, 97, I worked on the ATM cloud and then the BGP cloud, which you could look at in the Internet Engineering Task Force RFC 2547, around 1999 to 2000. Around 2001, 2002, I worked in the VPLS cloud. And now the modern clouds are the same clouds, just with a little bit of compute in there, but similar networking. Well, not exactly, but fairly similar. So none of this is new. And RAID, or redundant array of inexpensive disks, is also not new. And if you look back and you peel back the onion at your service providers, like your cloud service provider, they have RAID arrays running everywhere. So we're going to talk about what is RAID, how does RAID work, the types that you may use. I'll give you the kind that you would use in the cloud, but I'm also going to tell you about the other kinds because let's face it, 98% of organizations at this point use some kind of multi-cloud or hybrid multi-cloud solution. And you'll be using things like RAID 5, RAID 6, and RAID 50 in the data center, but you won't, even if you can't use them in the cloud. So we'll talk about what these are and what problems these technologies are designed to solve. We'll begin with RAID. So RAID is basically when you put multiple hard drives together to increase your speed and your capacity. So you may recall yesterday, we talked about the equivalent of a link of a private line being one wire, and then you could bundle two wires together in a link aggregation group to have double the speed, and then maybe three wires together to get triple the speed, and then four wires together in a single link to get 4 times the speed. Well, RAID is just like that. RAID is no different than putting more people in the boat to row the boat instead of having one person. And if you had 4 rowers in the same boat, you probably could row almost 4 times faster. And you might be able to go 4 times farther because your capacity. So RAID is really doing the same thing. It's taking multiple hard drives, either physical hard drives, like in a server, or virtual hard drives, which are block storage drives in the cloud computing environment, and we're going to pop them together to get maximum performance. So we'll talk about lots of different options, and I'm going to whiteboard them through you so you get it. I'll show you some graphics my team actually drew. But for the most part, there's RAID 0, there's RAID 1, there's RAID 5, and there's RAID 10. Now, RAID 4 and RAID 5 are pretty similar, so we're just going to discuss RAID 5. RAID 4 is better with SSD drives, where RAID 5 is typically used more for magnetic drives, but it doesn't matter. RAID is RAID. So we're going to begin with RAID 0. So RAID 0 is the simplest to understand. It's the fastest. And RAID 0 is effectively put 2 hard drives together, write to both hard drives, get double the capacity and double the speed. Put 2 rowers in a boat versus just 1. Or put 4 rowers in the boat versus just 1. And by doing so, we get max speed and we've got max capacity. Here's the thing. We've got 2 rowers in 1 boat, okay? So if the boat sinks or either rower kind of can't row, we lose everything. So when we put 2 drives together in RAID 0, which is called striping, if anything happens to any of the drives, we lose it all. So if you're going to use RAID 0, back up, because it's not the most safe thing in the entire world. So what does it really look like? So let's say I have data, and the data is coming in, and I want to store it on 2 different drives. So in a RAID 0 environment, I write the first block, as you can see, to the first hard drive, the second block of data to the second hard drive, the third block of data to the third hard drive, the fourth block of data, fifth block of data to the fifth hard drive, sixth block to the second hard drive. And you can see we're constantly going back and forth. So why is this cool? If drive A can do 500 megabit a second and drive B can do 500 megabit a second, guess what? We've got 1,000 megabit a second. So we double the speed. If we had 3 drives, we triple the speed. If we had 4 drives, we'd quadruple the speed. Now, if hard drive 1 was 10 gigs and hard drive 2 is 10 gigs, 10 plus 10 equals 20. So we get a lot of speed and a lot of capacity. But if we lose one of these, like if this drive were to go away, we've got absolutely nothing. And the reason we have nothing is half of our data is here and half of our data is on the other drive. And if we lose one, we've got nothing. So understand that as RAID 0. RAID 0, super, super, super fast. Highest capacity of the bunch, but lose something, we've got nothing. Not always the best situation. So generally speaking, RAID 0 is a little risky for the enterprise. And but you'll see RAID 0 used. Maybe you've got a video editing team that needs a lot of speed, so they're editing on RAID 0. When they're done editing it, they move it to a different drive. You may have to do something which requires high speed, and there's a time and a place where we'll use another flavor of RAID 0 called RAID 10. But all in all, typically speaking, RAID 0 is a little on the risky side. Now, the good news is the drives we're actually talking about here is logical drive, so it's going to be less risky overall. So I kind of hope this makes sense. So next is going to be RAID 1. And RAID 1 is something called the mirror, and it does not improve our capacity at all, and it does not improve our speed at all. RAID 1 is when we take the information on one drive, we copy it to another drive in real time. Pop it here, pop it here, pop it here, pop it here. So if we've got two 10-gig drives, what do we have together? 10 gigs, because one is just a backup copy of the data. Now, you've got no speed advantage with RAID 1 either, because what you're doing is you're taking the information on drive 1 and dumping it on drive 2 at the same time. So it's going to be the speed of your slowest disk. So RAID 1 is going to be expensive, because if I have 4 drives in RAID 0, and I would need 4 drives in RAID 1, RAID 0 to back it up. One hard drive backup one time. So it's slow, it's expensive, and we've got no capacity advantage. But I'll show you where it excites. So as you can look in this information, in this particular type of RAID environment, we're copying the data to the first drive, and it's immediately moving over to the second. So no speed, no benefit. But, and here's where this gets great. If this hard drive were to go, this hard drive, say, over here, all that's necessary for you to do is you have to break this mirror to stop it from mirroring, and then you boot up or run your data off of the second drive. So RAID 1, lots of redundancy, pretty much gets you back up and running in real time. Incredibly effective, but absolutely no speed or capacity enhancements. So RAID 0 is super fast, lots of capacity. RAID 1 is slow and no boosting capacity. So in the enterprise, in the data center, in our company and every other company, we typically run some flavor of RAID 5. It could be called 50, 40, 60. They're all very similar. The only difference is which drives we're using and how many redundant drives. But RAID 5 is typically what you see in the enterprise data centers. You can't use it on the cloud. And the reason they don't let you use it on the cloud is, remember we went through the storage speeds yesterday? And all cloud storage speeds are horrible. I mean, let's face it. They bring us back 15 years on speed when we deal with storage in the cloud for the most part. There's some workarounds, but it's typically slow. So RAID 5 adds a touch of latency, even though it adds a lot of speed and it adds a lot of capacity, but that's what we get ourselves here. So here's what RAID 5 typically looks like. And I've always loved RAID 5. RAID 5, we have to have a minimum of 3 hard drives. And whatever we have to have at least one backup drive. If it was RAID 6, it's typically 2 backup drives. But RAID 5 is 1 backup drive. And here's the way this works. And it's highly effective. So let's say we have data. So we add data to the first drive. Note we added data to the second drive, block 2. We partition our data and put it on drive 3. And that last thing where it says parity, that's backup data. So next, and we're going to spread the backup data on all the drives. You notice the next time we put our data on the first drive, the second drive, but now we put our backup data on the third drive, and then we put real data on the fourth drive. The third time around, we add data to the first drive, backup data to the second drive, real data to the third drive, real data to the fourth drive. And that next time we say we run the backup data to the first drive, and then we store real data on the second. So note, if you notice, every single time we've stored some backup data here, backup data here, backup data here, backup data here. So here's the reason I love RAID 5 and most enterprises use it. If we've got 4 10-gig drives here, in RAID 0, the capacity would be 40 gigs. Now here we're going to lose 1 drive's worth of data. So if I've got 4 10-gig drives here, guess what I have? 30 gigs of capacity, because I'm losing 1, 3 out of 4, 30 divided by 40. Now, we're also going to get an increase in speed, because if this drive can do 250 megabit per second and the second drive can do 350 megabit per second and the third and fourth could, in RAID 0 you'd be at 1,000 megabit per second, but not here. What's going to happen is we're going to get the speed of, say, 2/3 of the drives. You'd think it would be 3/4 because we have 3 drives, but there's a little low latency when it relates to overriding the parity. So assume we get 70% of the speed versus 75% in the speed if we had 4 drives. Obviously, as we add more drives, that penalty becomes less. And it's common to see RAID arrays with 50 and hundreds of drives that are sitting in these things based upon the size of the RAID array. So keep that in the back of your mind. RAID 5 is very reliable. It gives you very good performance. And if anything happens, all you need to do, let's say we had to pull out hard drive 3 failed. We pull hard drive 3 out of the RAID array. We tell the RAID card or the RAID software to actually rebuild the drive based on the backup data, and everything is back up and running. So I love RAID 5. Been using RAID 5 forever. Now, if you recall, RAID 0 was super fast, but it had no failure. And RAID 1 was super slow and low capacity, but it was 100% reliability. RAID 5 is awesome, but because the storage on the cloud is so bad, it's so slow compared to what we have in the data center, we can't handle that additional latency, especially if we're going to access systems over a WAN with even more latency. So that brings us into RAID 10. And RAID 10 is really cool. It's a combination of the fastest of RAID 0 and all the redundancy and backup of the RAID 1. That's why it's RAID 10, because it's RAID 1 plus 0. So how is this going to work? Well, we're going to have a RAID array running RAID 0 that's going to be super fast and low latency. We're going to have a second RAID array that's going to be identical capacity, and everything we write to the first array gets copied in real time to the backup. So now we've got the ultimate speed and the ultimate redundancy. Here's the problem. If I've got 10 drives in my first RAID 0, I need 10 drives in my backup RAID 0. So RAID 10 gets real expensive really fast. But it's becoming increasingly popular, especially in the cloud computing environment where we have slow performance and we need something. So kind of think about that. And what's that going to look like? Well, it's going to look like this. Let's assume drive 1 and drive 2 are 500 megabit per second SSD drives in RAID, the first run, and the backup is 500 megabit per second SSD drives. So now in the first RAID array, we're going to write our data to drive 1. So
Mike, you're sharing the wrong thing, Mike.
Thank you. So in this particular case, our data will be sent to drive 1, and then our data will be sent to drive 2. Note, block 1, block 2, block 3, block 4, block 5, block 6, block 7, block 8. So ultra fast going back and forth between these two drives. And notice the RAID 1 that's running between these drives. So you've got a backup RAID array doing the same blocks again and again. So double the speed, double the capacity, and unfortunately, double the price. So now that we've discussed RAID, and we'll talk about times where you might use it. So let's say you need a lot of IOPS for your database, and you're using a block storage volume. Well, if you can't get more than 160,000 IOPS, which is nothing, maybe we can put 4 of those 160,000 IOPS drives together and get, 150 times 4 would be 600, so it would be 640. So we're getting into more normal speeds. So that's an option. Keep that in the back of your mind. Or maybe we need high throughput. Maybe we've got to push uncompressed video or something like that, and we need lots of throughput. Well, we could use RAID for that too. So lots of use cases for those. Now, the next kind of storage we're actually going to talk about is going to be file storage. So any of us could take a system and we could share a drive on that system like you would on a Windows system. You could actually go to My Computer and right click on a drive and click share this drive. And if you did that on Windows, after you added your usernames and password, it would share whatever's in that shared folder or shared hard drive that you have with anybody that's on your network, assuming they have the privileges to access it. And that would use the server message block protocol. Now, if you were using a Linux system and you wanted to share it with other Linux or Unix systems, like Sun Solaris, you don't see it a lot anymore, but there's still some Unix and HP UX you'll still occasionally find out there. There's some BSD Unix you find out there, though most of it's Linux in today's world. But if that's the case, you're using the network file system that was invented by Sun Microsystem about 30, 40 years ago, which is now owned by Oracle. So you can keep that in the back of your mind. So you can make a file server out of any server. And there's lots of good reasons to run your own file servers. But what if you didn't want to run your own file server? Well, Azure has managed file servers for you that you can use, where basically they're fully managed, and all you do is you store your file sharing there. So that's really all we're talking about. It's a way to try to put these pieces and parts together. And it could look something like this. You could use this Azure file share as your file storage. And because it's a Windows or Linux-based file share, which uses a standard protocol, your clients in your data center could mount that file share and use it if it's a local hard drive, even though it's accessed over the network. Your servers on-premise could do it. Your server sitting in Azure could do it, because all they're really doing is accessing a standard file share. Remember when we talked about storage? Object storage is used for backup and archival purposes. Block storage is used as a virtual hard drive for your virtual machines, and file storage, that's when you want to share files with multiple users all at the same time, or multiple systems need to have access to the same information. So when might you use Azure Files? Well, anytime you need a file server and don't want to build your own file servers. You could get rid of your on-premises file servers if you wanted to. Probably going to cost you a lot more in the cloud to do it, but you could do it. If you wanted to test something in, say, a dev test environment, you could use it. But it's a great repository for you to put your things. Now we're going to talk about another type of storage called Azure StoreSimple. And what is Azure StoreSimple? It's going to be hybrid cloud storage. And that's really optimized for storing and accessing and managing, fairly large amounts of data. And it's got an option of doing all your backups and primary backups or snapshots or archival. You can archive it offsite. You can use it to back up or offload infrequently used data. And it's a nice way to do storage outside your environment. All it really is using Azure as storage. So you can see in this diagram over here, you've got your Azure data center. You've got some devices that are local, and they're synchronizing in the Azure data center. It's fairly simple if you actually look at it. Hybrid cloud storage. Now let's talk about how to get your data to the cloud. Well, let's be fair. If you've got a wire to the cloud like a private line and you've got good capacity to the cloud, send your data over the link that you already have. There's nothing to think about. But what if you don't have a link to the cloud provider? Or what if you have a 10 gig link to the cloud provider and it's full with actual traffic and you've got petabytes of data or large amounts of data to send? Well, that puts us in the environment where we can basically have a hard drive shipped to us, or a computer with a bunch of hard drives shipped to us. We can copy our data to the drives and then ship it back to them. And then the Azure personnel that work in the Azure data center can put it there. So realistically thinking, pretend this is a box. Copy your data to the box, stick this box, ship it to Azure, and they take it off the box. That's where we're going to really talking about when we talk about these data boxes. All the cloud providers had them. AWS had snowmobiles and snowballs. It's just basically a ruggedized computer or hard drive they send to you with high-speed networking. You copy your data to it, and you ship it back to the cloud provider. So that's what we're talking about with data boxes. Now, obviously, it's a hardware appliance, and because it's going to have high-speed networks or ways for you to copy your data on it, you're going to have to ship this data, right? So if I copy my data to this box, and then I ship it to somebody else, what would happen if somebody stole the box or shipment along the way? They'd have access to my data, right? So We have to understand when you get these data boxes, it stores your data in an encrypted manner, and anyone without the decryption key won't be able to access your data. And then it sends back to Azure and they sterilize it, meaning they get rid of your data. And it's not just a simple delete. It's about taking the drives and rewriting them with, say, all zeros 6 or 7 times to rewrite over any data fragments that would be there. All zeros, all ones. There's lots of patterns you can use. So we're talking about various appliances. There's a data box, there's a data box disk, there's a data box heavy, and there's a data box gateway. But all in all, we're really just dealing with a box. The traditional data box is a specialty computer with lots of hard drives in it that's got 100 terabyte capacity. You pop your stuff, your data on it. It's encrypted with AES 256-bit encryption, which is about as good as you're going to need right now for any great civilian level encryption. Now, there's also the kind of concept of the Azure Data Box Gateway. It's a storage gateway. What's that doing? Well, I want to show it to you. I'm going to draw it out architecturally. Basically, you're putting a server in your data center, and you copy your data to the server, and it pushes it over to Azure. So, I mean, that's really what you're actually talking about. And so in most cases, when you're dealing with a storage gateway, what you're dealing with this is, so let's say you've got your campus over here, campus. And generally speaking, and the way any one of these storage gateways works, you put it's typically a virtual machine that you stick that's running a storage gateway service. Usually AWS has got one. It's typically speaking how storage gateways work. And then you got your cloud provider over here.
Mike, you got a network between
these. So typically what you'll have is, sorry, I wasn't sharing my screen. You'll have your campus, and you'll typically have this virtual machine that's typically called your storage gateway. And you'll typically have either a VPN or or a private line to your cloud provider. And typically what happens, you'll have your users over here in most cases. Your users will basically mount this virtual machine, which is going to look like a file server. And then the file server in most storage gateway scenarios will copy the situation over the cloud provider, pop it onto object storage, and you can take it off. Now, the other way that you could do this if they really wanted to is you could mount your file server over here, mount as a file server, have your devices copy it, and then ship a device to. That's kind of the way most of these storage gateway data boxes work. So some of them you ship to it, some of them are actually done via the network. But that's really what we're talking about, is putting a virtual machine in your data center, having that virtual machine act as a file server, users connect to the file server, and the information is taken over. But some of these data boxes, you're going to put your information on and ship it over. Storage gateways typically do it this way across your cloud providers. So now let's talk about compute. And this is where the fun's really going to begin. But before we do, I figured now's probably a good time to see if there's any questions that popped up. Any questions for us, Chris, thus far? If you lose one of the drives in RAID 1, can you replace the drive and rebuild the mirror? So generally speaking, in RAID 1, what you do is you break the mirror and run off of the backup drive. But then what you can also do is add a new drive and rebuild the mirror. You have that option as well, typically speaking. So yes. See if any others come in. I'll give you a minute or two. See if anything comes in real quick on questions. If not, I will get right back to the content talking about compute, which is one of those things that I've always loved. Give you about 30 more seconds. All right. Well, okay. I'll answer this next question. Is it a good idea to get GCP, Azure, and AWS certifications, or just one is good? Well, first, we need to evaluate what career you want. Because some careers, the more certifications you have, the less valuable you look. For example, if you're a business architect or an executive architect, like an enterprise architect, and you've got 10 certifications, they're going to view you as a techie. They will lower your pay and or not hire you for the best jobs. By comparison, if you're in engineering, to a degree, more certifications are a little bit better for you. So it's based upon and dependent upon the career. Now, the other thing that I think we need to actually address, the last question, is you could get all 3 cloud provider certifications and truthfully know zero about cloud computing. So if you understand cloud computing, you'll be able to pass one certification like nothing and be able to pass the other certifications very quickly if you desire. So it's not ever going to be, should you get all 3? The question is, what are your goals? And after we know your goals, we can help you pick it. But I'd rather a person that's only certified in one cloud provider that knows everything they're doing than somebody that's got 40 or 50 certifications. In fact, there's a group of hiring managers that I know that if someone has 10 or 20 certifications, they won't interview them. And the reason is all certifications are ultimately intro level. They're talking about something and how to do it, hands-on doing. That's typically the entry-level careers. As you move up into your technology career, it's going to be more about your decision-making and more about advising clients and thinking about clients. So at that point, it's more about it. So if your goal is cyber, and I'm going to invite you on Thursday, but if your goal is cybersecurity, I'd walk around with a CISSP and one cloud provider thing. I'm not going to walk around with a bunch of intro-level cloud certifications based upon the name of the service and how to configure it. I might have a CISSP, a CISM, and a CCSP if I was a security architect. Now, if I was a penetration tester or an ethical hacker, I might have a CEH master and potentially a CISSP and other things that are going to be more, but the CEH master or the OFSCP would be more focused on handling it. So it's not enough to just say cybersecurity. We do need to know architect, engineer, penetration tester versus which is offensive security versus defensive security engineering versus security architecture versus governance and compliance. Every one of those things is going to be different and need different. So join us on Thursday and we can actually talk to you about your specific goals on our free webinar. But it's never a goal just to get a bunch of certifications without knowing what you're building. You have to build the ideal profile and the ideal brand. So since there are no more questions related to the actual tech content, we've got lots of times that we'll do to basically answer career questions. Let's get back to the tech then. And now we're going to talk about computing. So what is compute? Everything we do in tech needs to have some kind of compute behind it. The central processor, the brain that's doing the calculations, running the instructions. It could be a graphics processor doing parallel processing. It could be a CPU. But whatever we do, we need something that does the compute. Now, we'll have opportunities into infrastructure as a service, which we'll talk about, potentially serverless and platform as a service, and because there's lots of options of models that we can do our compute. But understand, no matter what we do, serverless, non-serverless, it's still running on a server. The compute has to be done, and the compute is where all the work's done for the most part of everything that we have. So we're going to begin with infrastructure as a service. And what is it? Well, in your data center, you got servers and virtual machines, right? In the cloud, you got the same servers and the same virtual machines. It's no different. So if somebody were to try to say, look, we're greener because you don't have to buy the 500 servers, the cloud provider has to buy the same 500 servers that you would have needed to rent it out to you. It's the same thing. So infrastructure as a service means renting the exact same stuff in the cloud that you would have been using in your data center. So here's the good news with that. You get the ultimate control when you deal with infrastructure as a service. You've got full access to those virtual machines, as opposed to more managed things and more serverless things where you're at the mercy of the cloud provider and hoping the capacity is not used up. But with infrastructure as a service, you've got the ultimate control. And when you're dealing with a virtual machine, what is it really? And we're going to walk through some virtual machines. You're going to have the server itself, And then what's going to happen is you'll be taking that server and you'll be renting a percentage of that processor. You'll be renting a percentage of the server's memory. You'll be renting a percentage of the server storage and a percentage of it. So it's a server. So the way this is going to look is going to be as follows. If you've got a physical server, and this is actually a type 2 hypervisor, which you might actually have on your computer, and I'll show you the difference between this type 2 hypervisor versus what you'd have on your computer. So let's say this was your PC right now. And if your PC was the physical server, you'd have your operating system, say Windows or Linux, and then you would install a hypervisor, and then you could run a virtual machine that's running, say, MySQL, and another virtual machine that's running, let's say, what do you call it? Cisco Packet Tracer for doing some lab stuff. You could have another virtual machine that's running Oracle Linux, all on the same system. Now, this is not the way server virtualization actually works. This is the way desktop virtualization actually works. This is called the type 2 hypervisor. Now, what's going on in our cloud providers' data centers is actually this. And this is also the way all industrial data centers actually do things too. You're going to have the server itself. This is the physical server. This is the thing you put on the rack. And this is where your hard drives are. This is where your DRAM's located. This is where your CPU, or most cases as a server, it'll have 2 or more central processing units. All that stuff's in the box. And instead of installing an operating system, what you typically do is you install a hypervisor. And this is the real way that we're talking about. This is going to be a type 1 hypervisor. And I'm going to show you a type 1 hypervisor in a minute. I'll take you to our data center, and we're going to work on one so you can actually understand this for real. Because I've interviewed 1,000 AWS and Azure certified people and asked them what a virtual machine was, and less than 5 could answer it, which means you can't design anything that you don't understand. So you take this server, you install this hypervisor, and this hypervisor is kind of like this wizard that says, okay, this server's got 100 cores. You can have 2 cores, you can have 2 cores, you can have 2 cores. Oh, you need 4 cores, you got 4 cores. You need 64 gigs of DRAM, you got 64. You need a terabyte, you got it. And as long as all the capacity resides in the physical server, this type 1 hypervisor can kind of do it. So it's kind of like the manager that's sending stuff everywhere you need. And underneath this hypervisor, you can install a little mini computer. So let's say in this case that our server had 128 cores and 6 terabytes of DRAM. It's a pretty big, beefy server. There's bigger servers now, but this is a good server. So what I'm going to now do is I'm going to create this virtual machine here, and it's going to have 8 cores, and it's going to have 16 gigabytes of DRAM. Pretty small system, but a lot of systems in the cloud are sized like this. Now that's your virtual machine. Now what will ultimately happen is you'll have that hardware, and then what will happen is you install the operating system, and it can be the operating system of your choice. And then what you will do is on that, you will install whatever your applications are and whatever the dependencies are. So, for example, you might install an application, but it's going to need to have a certain number of packages installed on it. And guess what? You want to run a second virtual machine? You can. And that'll be there. It'll pull 8 cores. So from the RAM, we've got another one that we can pull. We can create another one. And mind you, this server has 128 logical cores, right? So we can have a whole lot of 8-core servers that are here. Now, the only thing that I didn't tell you, which you probably should know about server architecture, is this. Let me draw it out one more. So you've got your server, and your server has a CPU. And what you see, the way this actually looks like, inside, if this is your main CPU, you're going to have little mini CPU computational chips. These are going to be called your cores. Oops, that's not what I wanted to do. And then I'm going to walk you through a real server so you can see it. So each one of these cores that you have here is an actual physical device that's doing processing tasks. That's an example of what we have. So we've got a bunch of cores sitting on this server. Now I'll count them up to see what we have. 1, 2, 3, 4, 5, 6. So we've got 6 times 3 is 18 physical cores. Now what happens is a task needs to be scheduled on a CPU core, and the task runs to completion. But what if when this task is run on that CPU core, it only takes, say, a percentage of the CPU core's capacity? Because only one thing can run at the same time. Modern processors enable the CPU cores to chop themselves in half. So you've got virtual core, and then you're going to have a second virtual core out of every single one of these processing cores. Because what will happen is if it's not being used at 100%, potentially we can have 2 different things running at the same time. A different thread here, a different thread here on the same physical core. So if we have in this computer 18 physical cores, we're going to have 36 logical cores. Why am I telling you we got double the number of virtual cores compared to physical cores? Because when you buy a server from Dell with 128 cores, you have all 28 of these physical cores and 256 of these virtual cores. When you buy a server on the cloud, they always, or in a hosting environment, they're only talking about virtual cores. So if you buy a $300,000 server from Dell with 128 physical cores, you've got access to 256 virtual cores. If you get a 128 core server from the cloud provider, which in many cases is going to cost a lot more than the will to actually buy it on your own, you're only getting the half core. So you're realistically getting potentially half to full capacity based upon the utilization and busyness of what's going on with these tasks. So you're going to have to test it, and don't assume that your cloud computing environment is going to perform anywhere near as well as your data center until you adjust for these factors. But if you adjust for the factors, you can get it. So what's this stuff really going to look like? Well, let's go to my data center over here. And the data center, what I did is I logged into one of my servers. I've got a whole bunch of these VMware ESXi servers sitting around. I use them as lab environments for my students. My students build clouds on these and other things, so they really understand cloud computing. Now, if you look at the server, you're going to notice something. The server itself has 24 physical CPUs in it. See that? Now, that means we actually have 48 virtual cores. And the technology companies enable you to chop the core into virtual cores, because if one of the cores isn't running completely and it can only do one thing at a time, by chopping it into virtual cores, you can potentially get more out of the same CPU. So that's why we have virtual cores. So we've got 48 potential cores we can use. You can actually look at the CPU. These, by the way, these servers that I'm running, I actually bought them from Amazon. They're about $400. Now, if you were to go to Amazon and get an i3 instance with 24 cores, it'll cost you about $1,100 a month to use this system every month. So over the course of 3 years, it'd be $11,000 times 36. You can buy these servers and play if you want from Amazon for about $400. So each month, it's about 50% of the cost that would be to actually rent one. So kind of think about that. So it's about 1/72nd of the cost for me to buy these and use these as lab servers than it would be to rent them on AWS or Azure. So I have a data center in my house. My cat likes to unplug the cables. It makes for a great troubleshooting case. But you can see I've got a total of 55 gigahertz. We've used 45 megahertz, which is nothing. So basically the entire server capacity is free, and we've got 0% CPU utilization. Now you can see right now that we've got 118 gigabyte left of memory. We've used 9.5 gigabytes. Some of that's for the hypervisor and other things that are running. You can see we've got a 1 terabyte effectively, because that's not 924 gigs is the 1 terabyte fully formatted drive in here, and we've used 80 gig. Well, we've used a lot of it. We've used 87% of it. So that means my students actually have a lot of machines that are sitting there. So in a data center, if we want to create a virtual machine, we're going to create a virtual machine. We'll name it, let's say Cindy the cat. Cindy cat. You all know I like my cat Cindy. We would tell it, say, what type of operating system we'd want, and then we would select the operating system we would use. Then we would tell it where we want to store it on, which in this case is the first drive. Notice now, even though I only have 24 physical cores, I can give this virtual machine 48 cores. That's because the hypervisor will work with the hyperthreading capability of the CPU cores itself. So let's say I wanted to make a machine with, say, 8 physical cores. And how much DRAM would I want? Well, I'll swap it over to gigabytes. Maybe I give the machine 32 gigs of DRAM. Then I'm pulling the hard drive space directly off of what I have here. Maybe I make this 20 gigs. And realistically speaking, the only thing that I need to enable is a boot drive. So let's see what kind of systems I actually have over here. For fun, I'm just going to put Ubuntu 22, the desktop version. And now watch what happens. If I turn this computer on, it's going to boot up like a regular computer, even though it's going to be sitting inside of that server. It is a logical computer. And I'll let it run for a minute so you can kind of see that it's going to look and feel like a computer. Here we've got Linux. It's going to check the disks of the file system to make sure the disks do what they say they're supposed to do. And it found that my disk is healthy, which I know it's healthy. And at this point, I'd literally be able to install this like I would any other virtual machine. And this is what we've been doing in data centers since 1999. All data centers have been running like this since 1999. VMware invented the first hypervisor in 1999. Prior to this, and we don't need to install the operating system here, and I'll shut this virtual machine down so we save the resources on my server and I'll probably delete this. So we don't take resources from my students that might need it. But there you can see that is a type 1 hypervisor. This is what the industry is actually using. And now when you get to the cloud and you see an Azure virtual machine or a Google Compute Engine instance or an AWS EC2 instance or an Oracle virtual machine, it's the same stuff. And that's why I'm saying I don't really care which certifications you get. I want you to know the technology. Know one cloud, know them all. Kind of hope that was pretty helpful to walk you through so you could really, really see it. So now you know what is a virtual machine. So when it's going to come to compute in the cloud, we're either going to have virtual machines, we're going to have containers, which we'll talk about what they are. We're going to have like this hosted app service where you just upload your code and stuff's just going to work. And we're going to have these little mini things like Lambda functions and AWS, Azure functions, what have you, function as a service in a private cloud. So none of this stuff is new. So we talked about virtual machines, but when you get them in the cloud, how do you get them? Well, generally speaking, they're on demand, meaning you can start them when you want and stop them when you want, okay? Now, could I start a virtual machine in my data center and stop it anytime I want? Absolutely. Nothing's new here. The only difference between virtual machines in the cloud and virtual machines in my data center is the following. In my data center, I may not have extra capacity. In the cloud, they have more capacity. So there is that. There's one other thing that you should be aware of when you deal with service providers and cloud providers. That's the concept of oversubscription. So normal businesses like and homes like your house, let's say you've got a gigabit Ethernet connection. You're not reselling it to 10 neighbors and giving them each a gigabit where you've sold 10 gigabits of capacity, but you only have one. Well, that's the way service providers do. They assume that most people won't use full capacity of their systems at all times. So they oversubscribe. So imagine this, and maybe I should walk you through this oversubscription so you could see it. Here I'm going to create a virtual machine. Let's just for argument's sake call it over sub 1 so you can see it. Because this is how internet service providers and cloud providers actually make their money. Let's just call it, I'll just pick one. Other 64. I don't really care what I'm trying to show here. Now let's say I allocate, because this is oversubscription at its best. And this is one of the reasons cloud computing doesn't typically perform as well. Now I'm going to go next. I'm just going to say finish here. Now what else can I do? I'm going to create another virtual machine on this same server over sub 2. And I'm going to also on this same server, I got to select an OS family. I'm going to go other because I don't really care, just to prove the point. All right, select a version. Okay, fine. Do we see the other 64-bit that I clicked last time? No, I don't care. It doesn't matter what we're using here. Next. And look what I can now do. I can put another 30 cores here. So now I've got two 30-core servers on a server that only has 24 physical cores. I've allocated 60, I've got 24, and I can do this all day. So please understand, when you're in a public cloud, they will oversell more capacity than they have, because statistically speaking, most virtual machines won't use their full capacity at a time. In the internet service provider business, they typically sell 10 times more capacity than they have. So if you've ever heard of cloud computing being bursty, meaning like sometimes it's super responsive and sometimes it's slow, one of the reasons is often that either their network is congested due to oversubscription, or their servers are busy due to oversubscription. Generally speaking, you'll have more control over your infrastructure as a service and virtual machines than you would serverless, but understand, the only way they can make money is to build the same data center that you have, and then they have to pay staff to go sell it, which is a lot, billions of dollars, and then they have to pay a marketing department, and then they got to resell it to you and make money. So the only way they can do that is to sell more than they actually have. And 99% of the time it works out fine. But if you're an architect and you're planning these things, you have to understand that these things could happen. Doesn't mean I don't love cloud computing. Doesn't mean I don't love internet service providers. But as an architect, you need to know the strengths and weaknesses with every approach. Because what is architecture? We don't code, we don't configure. We have to evaluate all the trade-offs of the technology solutions we have and see which is going to be the best one for our business. So hope that actually makes sense. So if you need control, use a virtual machine. You've got the flexibility here. You don't have to buy the machines ahead of time. Now, here we get into marketing fluff, and I have to teach you the marketing fluff for your certification exam. The only thing that matters when it comes to your server is the speed of the cores, the performance of the cores, the way the cache DRAM on the server itself feeds memory into the cores, the speed and amount of DRAM you have, and your hard drive frequency. So if you're doing it for real, you're going to say, well, I need this many cores and this much DRAM and this many IOPS and this much throughput on my jobs. That is reality. Now, the marketing departments of the cloud providers assume people weren't smart enough to know these things. So basically speaking, what they did is they now have different types of computers for you to use. Things like general purpose or compute optimized. So I'll tell you what they are. It's all marketing fluff. It is meaningless nonsense. What matters is CPU cores, DRAM, the frequency of your CPU cores, that kind of thing. So you're always going to have to look at your processor performance. You're always going to have to look at your DRAM performance. You're going to have to understand the networking performance that's associated with your server. Not whether they called it general purpose or compute optimized. But now we got to prepare for an exam, so now I'm going to give you the fluff. Amazon does this fluff, Google does this fluff, Microsoft does this fluff. CPU cores, DRAM, that kind of thing, that's what you're looking at. Because mind you, a CPU core from 10 years ago may not perform the way a CPU core from today does. A 2 gigahertz CPU core doesn't perform the same well as a 3.5 gigahertz CPU core. So just keep that in mind. So now we're going to talk about general purpose compute. General purpose compute is what they recommend for stuff that's basic, like development or testing, small or medium databases, low to medium traffic web server. And what is general purpose? Typically, it's an older server with a good balance of CPU and memory, typically speaking. But it's a marketing term. It has no real technical meaning whatsoever. Next kind of service we have is what's called compute optimized. Now you got more CPU power and more memory power. Again, look at the actual CPU in your servers and the actual DRAM, not marketing fluff. But understand from a marketing fluff perspective, compute optimized gives you a good balance of CPU and memory. And it's really designed for like a medium traffic database or a network appliance like a virtual firewall, maybe some batch processing, like you got to crunch a bunch of numbers or some application server. Now, the next version is what's called memory optimized. And what's that? You'll have a whole bunch of DRAM in your servers and a good amount of CPU performance. So where would you need that? Well, anytime you need a system that needs a lot of DRAM, you might want to choose one of these memory optimized things. So why would I need a lot of DRAM? Maybe I've got a database that is huge and people are constantly pulling information. I need to store stuff. Maybe I have a server that's going to function as a cache. that's going to store information in memory so the other servers don't have to answer. Maybe I'm trying to do analytics of cool stuff in memory and try to make better price predictions or predictions of field or predictions of anything. There, I need a lot of memory. So I need a lot of DRAM to my CPU cores. So the cloud providers call that memory optimized. Now, generally speaking, with a server, if I have to do a lot more disk I/O or writing to the drive, I'm going to use faster internal drives. Now, remember, we can't actually store stuff inside of these systems, but certain systems have better networking performance than others, right? And if we use block storage mounted to our virtual machines, we're going to be accessing the storage, right? So I'm going to need a lot of input and output, which means the server is going to need fast networking. So you could take an older server and pop in a 100 gig network card, not old, but a newer, but not as fast. And all of a sudden you've got high networking performance. But here they've already pre-made these virtual machines. So storage optimized means high disk throughput and high I/O. Where would you need storage optimized? Well, you got a big giant database, you got a data warehouse, you got a lot of transaction kind of stuff that's going on. And high performance compute. What's that? That's going to be a modern high performance server that you get on the cloud. Why would you need high performance compute? Maybe you're running some weather simulations, or you're running some genetic simulations, or you're looking at the seismic processing of things going on under the ground. Maybe you're dealing with some fluid dynamics calculations, any kind of high performance compute. What's that mean? Powerful CPUs that you're going to deal with, like the new AMD EPYC systems. So that's really what we're actually dealing with. So that is virtual machines. Chris, how long did I spend on virtual machines? Because containers is next. Let's do some questions, I think. Bring this to my desk. Bear with me. My team's going to bring up some of the questions. How do you know what to choose storage from between block storage and NFS? Very simple. If you've got a virtual machine and you want it to have a hard drive, pretty much the only option you have is block storage. Now, I have a server and I want to share that to 100 other devices. Now, I want to do it via a file share. If it's Windows, I use NFS. I use server message block. If it's Linux, I use NFS. Block storage is a logical hard drive, even though it's network-based, that's used by a virtual machine for itself. File storage is how do I share it amongst multiple files? Like 50 servers need to access the same thing for file storage. Excuse me, Chris, we can go to the next one. Why is there double virtual cores? So it goes back to what I was describing with the regards to the cloud to the manufacturers of the CPUs. So I've only got a certain number of physical cores. What happens as a process or a thread or a task is going to be sent to the CPU. Now, while that task is sent to that CPU core, it can't do anything else. So let's say I'm sending a task to the CPU core, and while that task is running, it's only using 10% of the capacity of that CPU core. The other 90% is wasted because it can only do one thing at a time. So I want you to think about that. Let's say you've got a guy who's got a 500-pound bench press. It's no big deal. And in the powerlifting world, it's kind of light. But if he's only bench pressing 10 pounds, he can't be squatting while he's bench pressing and doing this kind of exercise, right? He can only do that 10 pounds that's on the bar. But he can do 500, but he's only using 10. So what the people that made the processor, specifically Intel and AMD, had said, well, that's ridiculous. Why not just let us split the core if it's under load into two logical cores and run a task on both cores? Now, if that core can do a 500-pound bench press equivalent and it's doing a 500-pound bench press, you split the core. It's not going to help it in any way, shape, or form. But what happens is most of the time in systems is we're never truly maxing out the capacity. So there's usually something left over. So that's why they do virtual cores, which is doubling the effective number of cores. But it's not really doubling the cores. It's doubling, lots of little things it can do if each core is not being used fully. I'm going to the next one, Chris. What's the difference between a hypervisor type 1 and a hypervisor type 2? So you'll recall, and I'll actually go back to my diagrams and so in this particular case, this is what you call desktop virtualization. I'll pop this in here, make it easy for you. And in desktop virtualization, this is your actual PC. So the only time you'll ever use a type 2 hypervisor in reality is, let's say you've got a notebook and your notebook is running Windows, right? So we'll replace server with notebook. Windows is your Windows OS. And then you go and get Oracle VirtualBox, or you get VMware Workstation. And on that, you want to run some test virtual machines on your desktop. Maybe you're a software developer, you've written code, you want to test it in a virtual machine. Or maybe like me, when I was younger, I had a Red Hat Linux machine, but I had to write Word documents and PowerPoint documents, and you can't get away with a Linux machine in the professional environment. Like you could if you're an engineer, but you can't as an architect because you're constantly writing documents and making things look pretty. So what I used to do in my youth was I'd have a Linux machine. I'd have my notebook. It would run Red Hat Linux, later Ubuntu Linux. I'd put this hypervisor and I put Windows in a virtual machine. And with Windows, I could write my Microsoft Word documents. I could create a Microsoft Visio diagram. So this is desktop virtualization. Why is this inefficient? Why would you only use it for desktop? See, the hardware here, this itself is fast, but your operating system is pretty darn slow. Like you can get a fully maxed out Mac and you click something and it's not fast before it opens up. And if you were to take that same Mac and install a different operating system like Linux, it's going to feel like it's 10 times faster. Well, it's not any faster. It's just that certain operating systems themselves, they have to schedule tasks, schedule information. In the process of doing it, they might even security check things. So this host OS is going to slow a lot of stuff down. So because of this, it's great if you're a developer or you're an architect like me and you run a Linux system, but you needed to run a Windows application to create a virtual machine. But your performance here is terrible. Now, if you went to a type 2 hypervisor, which I drew out for you guys a little earlier, here we've got the server and then we have the hypervisor. But note, there's no operating system on the server. So we don't have the overhead of the operating system and we don't have the operating system slowing stuff down. It's going straight to the hardware. So the type 1 hypervisor is what's used in your cloud providers. It's what's used in all modern data centers. The type 2 hypervisor is what you did in college when your college professor said, here, I need you to build this system that does this. Or you're a developer and you want to run a virtual machine sitting on your desktop or a collection of them. Or in this case, let's say you wanted to be an offensive security professional and you had your desktop with your OS and you created a Kali Linux instance and a couple other virtual machines that you're going to hack into from your Kali Linux machine. That's your type 2 hypervisor. Commercial user desktop use versus industrial use like a type 1 hypervisor. And that's a good question. Let me see. I lost my screen that I was seeing these questions on. With VMware shutting down ESXi, what options for organizations to maintain a virtual environment? Well, VMware is not shut down. They shut down the freeware version that no business used anyway. So all businesses were using VMware or vSphere. So this is no impact to a normal business. It might be an impact to a mom and pop shop like us, where we're a small boutique firm, but in reality, VMware's hypervisors are huge. But most businesses in today's world are actually going to run a private cloud, meaning they can go to Nutanix, they can go to OpenStack from IBM Red Hat, or they can get even a free cloud provider. And what they can do is they can install the cloud software and then have all those auto scaling features and functionalities on the public cloud. So they're typically going to be using either VMware, the industrial versions, the vSphere stuff, which is not going anywhere, or they're going to be using things like Nutanix or OpenStack. Now, Windows servers themselves also have something called Hyper-V, which is a virtualizer. But that's really what we're talking about in the industrial world. There's some other hypervisors like Promox, but big business, real reality world, we're going to be using VMware, vSphere. We're going to be using Nutanix. We're going to be using OpenStack. What we have to understand is when we look at these things from a consumer perspective, it looks expensive what VMware is charging. When we look at it from a business perspective, it's still nothing compared to using the public cloud. Red Hat also has their virtualization. Ubuntu has virtualization. So you can think KVM, QEMU, Linux hypervisors, lots of data centers use them. Hyper-V on Windows. But VMware is not going away by any stretch of the imagination. It's only the freeware stuff that's going away. And businesses don't run on freeware anyway. And here's the reason real businesses don't run on freeware. You got to be able to call tech support when something breaks. And if you're running the free version, who are you going to call? Ghostbusters? And they're not coming. So don't worry about it. VMware is still strong and here to stay. And Broadcom is very strong. But I think you will see more in the Nutanix and OpenStack. So the difference is where the OS lies with regards to type 1 and type 2. Yeah. If you don't have an operating system, it's a type 1. If you do have an operating system before the hypervisor, it's a type 2. Don't even compare these two in performance. One is like a Ferrari and the other is like a bicycle. So all businesses use the Ferrari, the type 1 hypervisor. The bicycle is what you do if you don't have a choice. So in a type 2 hypervisor, what's called the bare metal? The physical server itself, that server you buy from Dell or Lenovo or HP. The server itself is bare metal, because if you open a server itself, what are you going to see? Well, what you're going to see is a motherboard, you're going to see DRAM, you're going to see CPU. You guys all know what a server looks like inside? You know what? I'm going to grab a server real quick, because the type 2 hypervisor is called the type 2 hypervisor. Bare metal is the server. Bear with me 1 second. I'll open up a server so you can see it. Okay, so here's what your typical server looks like on the inside. Now you'll note there's a board, this main board. This main board is called the motherboard. It's where every part plugs into. Now you'll also notice you've got these little sticks over here. This is DRAM. Now you'll also notice over here you've got something plugged in. That's the video card, and this is what's called an NVMe drive. Now, if I were to take these off, and I'm not super mechanical, you'll see this airflow thing here and the airflow thing. That's sitting on top of the central processing unit, or the brain of the computer. And note there's a cooler here and a cooler here, because this system has 2 CPUs. So what's different about a server is the parts typically stick around for a long period of time compared to, say, a normal PC. And they're tested to be stable. They typically have more than one processor in them. And they typically have the ability to pop a large amount of DRAM. There's 8 DRAM slots into this. This happens to be a precision workstation. It's a Dell. But uses server processors, so I use these. So I thought that might hopefully help. Let me pop this down. So hope that kind of helped. Were there any other questions that popped in? No. All right. Do you guys all like the server? See the concept of why it's got multiple pores? Did that hopefully put things together for you all? All right. Well, no more questions, please. Give me a hashtag. AZ-305. Hashtag AZ305. So your CPU won't, so that's another one. And if you haven't liked the video and you're having a good time, please like it, subscribe to the channel, and hit the bell to be notified. Amos, it's good to see you here again today. Happy to see you. So kind of hope that kind of helped put things into position for you. I really want you all to understand the underlying technology so you get it. So now we're going to get in talking about containers, because I really want you to understand that, because we basically have two means that we can actually communicate or do our compute, and it's either going to be in a container or it's going to be in a virtual machine. And there is a difference in how they perform and the way they're actually orchestrated. So a container is going to be a little different than a virtual machine, but it's going to be a similar solution. And a container is where you take the application, all of its dependencies, and you pop it into something like a container and you ship it. So if I got a bag of cat food, the bag is the container and the stuff inside it. So we're talking about something that's fairly similar. So let me explain containers for you, and then I'll get into the Azure container instances stuff. But I really want to know that you understand it. So if you'll go back, if you'll and we're going to actually, I'm just going to draw it. I want you guys to get it. So going into this particular environment, I'm not really sure what happened over here, but so be it. So if we go to this environment, let's say we go back to our server. We've got our server here. And you'll recall, because I want this to be fairly clear, and then we're going to get into the two parts of containers, or the three parts of containers, actually. You'll recall normally we've got this hypervisor here. And then we have a virtual machine. This is going to be the VM. And on the VM, we're going to have the dependencies. And then we're going to have the application. So this is traditionally the way it works. And so what's really going on here? We've got the operating system. Let's say it's Linux. And now you want to run an Apache web server on Linux or Nginx or something like that. Yeah, if you ever installed an application on Linux, you know that you have to install certain dependencies. This will work, but you got to put this, and this. Maybe on Windows, you wanted to install an application, but you needed to install Python, .NET, and something or other. Well, that's the dependencies. And then the application is the actual code that you're running. Now, if you look at this, let's say we've got a whole bunch of these virtual machines running on side of a server. I want you to see where the efficiencies are versus the inefficiencies. Each virtual machine, what does it need to run? It needs something to run. It needs an operating system. So each virtual machine needs an operating system. Do you think this operating system is free? Do you think this operating system doesn't use CPU cycles or CPU computations and DRAM? Got to tell you, you can build yourself a virtual machine right now and it's going to use 4 or 6 gigabytes of DRAM just to run Windows. Now, if I'm using 4 gigs of DRAM just to run Windows with nothing else, and I've got 10 Windows virtual machines sitting there, I need to allocate 40 gigs of memory just for Windows. Yeah. So what if there was a better way? What if instead of having all these things that need to reach their own operating system, we could do something different? Now, there are times where virtual machines, like we just talked about, make sense. A lot of those times. But there's other times where a more efficient approach could work. So what if we did this? And we can still do it on a server, and this is typically speaking what it's going to look like on the cloud. And it typically looks like in the data center. So let's say we have our server, which is the bare metal that I showed you inside the box, and someone asked about bare metal. And I have the hypervisor. And one of the reasons people like to use VMs, and I'll tell you, so let's say this hypervisor now has 256 physical cores, and let's say 6 TB I put in servers. 8 I've not done. That doesn't mean it's not possible. I'm just not sure. So let's say that server, and it's got a hypervisor. And we create a virtual machine here. And I'm going to make this virtual machine have 500 cores on it, 500 logical cores, and 7.8 gigabytes of DRAM. Now, why would I create a virtual machine that's so big? Well, in a normal server, if you want to copy this server, you got to basically copy 8,000 million files where you can actually use. And but if it's in a virtual machine, all you have to do is move a single file to go from one server to the other. So virtual machines, got a server, got to take down, move the file to another server, and it runs. So lots of move, add, and change reason organizations, people like hypervisors. Plus, in the cloud, for the most part, you're not going to get bare metal. And let's say this is the Windows OS, just for argument's sake. Now, I already have the operating system. Now, because we already have the operating system, what if I could just take an environment and put the dependencies on it? And then I can put the application code. And I can keep it in a little box that's called the container. And everything in this box is completely segregated by the container runtime module, which I'll show you what that's going to be in a minute, but I wanted to show this. And each and every one of these little containers is completely isolated from each other. So if something goes haywire in container A, it shouldn't affect container B, which shouldn't affect container C and couldn't affect container D. So, wow. Now I have the opportunity to put a lot of applications all in a single server, and I no longer need the overhead of all these operating systems. So if you understand what I meant by containers are efficient, give me a hashtag containers are efficient. They're very efficient because they're going to pull what they need from the operating system libraries, and then all these individuals are contained there. And guess what? They don't need CPU. They don't need DRAM to run an operating system. So a container is the equivalent of a lightweight virtual machine. It's highly, highly efficient. So I hope you actually understand that. So understand that. Now, the way the containers really need to understand or are going to work is, in order for this to happen, we're going to also need something called a container runtime module that's going to enable the operating system. And this is going to be a container runtime module. So that's going to be a little software package we're going to pop on that virtual machine, the container runtime module. Anybody got an idea of one? Docker. Docker is that container runtime module we use, typically speaking. There's others we could use as well, but Docker is a container runtime module. So when it comes to containers, there's going to be two parts of this whole container strategy. There's going to be the orchestration. Orchestration will get in there. See this little VMware hypervisor that enabled me to separate things, that's going to divide my memory and allocate it to the various virtual machines? That's an orchestration. Now, if we're on the battlefield, we've got a general or some admirals that are up in that tower somewhere that are telling the warriors in the field what to do. That's orchestration. You may go to an opera or a symphony, and you've got a conductor that's telling the flute people to play louder, the harp people to play. That's orchestration. So in technology itself, we will almost exclusively always need something that does the container orchestration, the virtual machine orchestration. If you're in networking, you run a routing protocol like OSPF to get your traffic from point A to point B. That's That's orchestration, or it's a control plane. BGP does the same thing. So we're going to need to have something that's the master there. And that's going to be called your control plane. And then you're going to actually have your devices that actually do the work, which are going to be the data plane. On routers, they would call them forwarding plane. But your data plane could be multiple VMs. And your control plane could be a lot of different things. It could be Kubernetes, and I'm not sharing it on screen, am I? So bear with me. In the data plane is going to be your virtual machine. Your control planes could be Kubernetes. It could be, and don't recommend it, AWS is an elastic container service. Azure's got its own proprietary thing, so we can use the control plane to orchestrate it, and the data plane is where the work's done. So that's typically what you're happening. So typically speaking is what's going to happen is for your control plane, you're going to have at least 3 devices or 3 virtual machines that are running it, and I'll show you why. And let's say this is Kubernetes for right now. I typically use open standards things because they work everywhere. So we've got our Kubernetes control plane here, and our data plane is potentially virtual machines, or it's our data plane where our Kubernetes pods would run could also be a serverless compute, which basically means it's going to sit on some virtual machine. You just don't know about it. The data plane is where the work's done, the computers that are doing the work. And what'll happen is this control plane, let's say we need 5 containers of something. And we've got too much work coming in on the control plane, and the data plane doesn't have enough with 5. That enables it to say auto scale for 7. And if the control plane needs to have, because you tell it I need 5 containers, and one of the containers sort of crashes and you're down to 4, the control plane will kick it back up to 5. It'll start it. So that's realistically what we're talking about. So please understand the point of this. We're obviously going to split our containers across multiple virtual machines or multiple physical servers, because if we put them all in one and it crashes, we're going to have a problem. But that's the foundation of what we're dealing with the data plane as well as the forwarding plane. And in everything we need, we have it. So now that you understand what the container actually is, and the need for these container runtime modules, the need for the orchestration, that's what we're talking about. Now, why do we need at least 3 in Kubernetes? And generally speaking, 3 control planes for anything. A control plane for my OpenStack cloud, you need 3 of them, because these things have to run an election. And what happens, they pick some factor that's going to determine who the master node is or who the primary control plane would be. And how do you have an election if you only have 2 people? Well, if this one says I want to be it and the other one says I want to be it, who determines that? So whenever we're dealing with control planes like in Kubernetes or things like that, guess what we need? An odd number. 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, what have you. So there's that. And mind you, if we have 3 different clouds, we probably need some Kubernetes clusters or master nodes in each cloud, because if all these things are all in one cloud and the cloud goes down, what's going to do the orchestration for the other one? So that's kind of something we should talk about. So Docker is the runtime and the control plane is something else. So you may actually have Kubernetes doing the control and Docker, which is where the runtime, or Kubernetes can do it all in today's world. So now that we talked about that, now we're going to talk about Azure Container Instances. So Azure Container Instances is going to be a server that enables a developer who knows code versus infrastructure to pretty much deploy container on Azure without understanding servers, without understanding virtual machines, without understanding any of the control plane that gets involved. They pop their code in a container and it just runs. It's serverless. I mean, it runs on a server. You just don't know about it. And you're secured by whatever they're using to keep you from separate from each other. The other customers all on the same server. Now, what does that mean? It's serverless. It means it still runs on a server, but now you've got no control. You are hoping that they do it great. Remember, hope as a management strategy is a little questionable. I mean, you can walk down the street and say, I hope nobody hurts me. I hope I don't get attacked. Or you can become a martial arts expert. Hope as a management strategy is not my favorite. I happen to be a martial arts expert just because I love it, but that's neither here nor there. But we all have certain things that we love. So Azure Container Services gives you an ability to pack, deploy, and manage cloud container-based applications in the cloud without thinking about it. So what does this mean? If I don't need to understand it as well, I don't need to hire people that are as good. So one of the reasons people like cloud computing is theoretically we don't need people with the same level of intelligence and capabilities as we did in the data center. The reality is cloud computing is the same tech, so it's not that much easier, and we still need smart people and highly trained people, and we don't have them. We have lots of smart people, but a lot of people struggle in training because nobody teaches the cloud what it is. They just teach the certification stuff, name of a service, how to configure it without talking about it. That's why we're focusing on this. So these Azure container instances are optimized for basic, simple applications, automated tasks, and it can be orchestrated via the Kubernetes. So this is where you're going to run. If the equivalent of container instances is like Amazon Fargate, serverless place to stick your containers, but you lose all control over it. And you still need a control plane. So we will at some point talk about Azure Kubernetes Service. We will talk about why it is a great service, but why, whether it's Google's Kubernetes service, the Azure Kubernetes service, or the AWS Kubernetes service doesn't work multi-cloud. Because if you lose that single cloud provider where you're using their Kubernetes service, you lose everything. So realistically speaking, what do businesses do? They either run their Kubernetes service, and if they want something managed, they go to IBM and they get OpenShift. They run that on virtual machines on all clouds, and then a single cloud goes, who cares? You're still up and running with your Kubernetes orchestration. Now, the next compute service we're going to talk about is Azure App Service. Now, this is really what we're talking about when we talk about platform as a service. Infrastructure as a service is basically they manage the basic systems, the actual network. They manage the hypervisor and the hardware, like the BIOS on their systems, and you manage your virtual machines. Platform as a service is basically they manage the operating systems on their virtual machines. They manage their virtual machines patching, and you just stick your code somewhere and it just runs. It's running on one of these same systems. You just don't know it because there's less for you to manage, which means you have got less control to optimize the performance too. But you've got more simplicity and elegance. So it's a trade-off. Is it worth the trade-off? I don't know. What's the business's level of sophistication? What kind of people do they have? How much granularity do they need over the performance of the system? This is the architecture things to think about. So platform as a service, you pretty much have your developer write their code, they upload it, and poof, it works. So great for website applications, REST APIs, back-end kind of systems, because really that's what's actually going on behind the scenes. You've got your app service, you put your code in here, maybe your website is sitting in Azure App Service, your HTML type page, and maybe it's connected to a back-end server, either like an Azure SQL server, which is fully managed and serverless, or you put MySQL on a machine, something to that effect that we're kind of talking about. Kind of hope that kind of makes sense. Bear with me a second. Oops, that was not supposed to happen. Well, I guess we'll see what happens. So if you're going to use the Azure service, and let's say you've got an HTTPS-based website, what do you need to make that HTTPS happen? Remember yesterday I said if I want to talk to Alonzo, I want to make sure Alonzo is who he says he is, not somebody pretending to be Alonzo that's not Alonzo. Now, in this particular case, how do we do that? How do you do it on a website? Well, you do it on a website by doing the following. You put a certificate back on that website. So the Azure App Service Certificate Portal, so on the portal is there to give you a certificate for your platform as a service-based systems. The next thing I want to talk about is an Azure function. So what the heck is an Azure function? Well, it falls into the new category called function as a service. If you're on OpenStack, you have it. If you're on Nutanix, you have it. If you're on Google, you have it. If you're on AWS, you have it. AWS calls these things Lambda functions. Azure function is the same thing. So what is it? It's a serverless solution. So what does that mean? What it really means is it runs on a server, but they don't tell you which server it's running on or the capacity, speed, or performance of the server. So you don't have to think about it. You don't have to worry about it. You don't have to manage it. And what happens is the developers write some code, they upload the code, and every time this thing runs, you pay. Every time this thing runs, you pay. So what's the good and bad of this? If you have something event-driven, if this happens, then do this, and it doesn't happen all the time, this is great. Why is it so great? I don't have to pay to have a virtual machine running 24 hours a day in the cloud. Sounds great, right? But you pay every single time. So what happens if something runs 24 hours a day, 7 days a week, and goes again and again and again and again, and ain't all these functions as a service? Well, it's like driving in a taxi that would be riding at 500 miles an hour, and you'd be watching that meter go woo, 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 and it'd be pretty darn scary. So these functions are really great for what's called event-driven. If this happens, go do this. If you've got a person and they go to, say, object storage, blob, and they set the item to the wrong permissions, and you have this little serverless app that kicks on an Azure function that says, ding, notified that it was public permissions, change the permissions so nobody gets hacked. This is great, right? So understand that serverless can cost less if you don't use it, or if you use it a lot, it's going to cost a fortune. So you're going to hear a lot of people say, serverless is cheap and it's great. Well, it could be or it couldn't be. There's a reason Amazon, who did everything on this microservice serverless kind of like function-based thing for Amazon Prime, thought it was great. And then a couple of years later, they realized it cost them 90% too much to run it, and they went back to a monolith. So architecture is an understanding of all trade-offs and what happens. But this compute on demand function is good. So I like to view functions and serverless the way I would view an Uber. I don't really take an Uber a lot. I have a car. Everything I like to go to is 30 minutes away. I live in Florida and everything's 30 minutes away. It just is that way. I go to the gym, a special gym that deals with people that are injured. So I go to the gym, it's 30 minutes up and 30 minutes back. If I were to take an Uber, that trip would cost me $60. I also go to a specialty yoga studio that's an hour away. You can get an Uber there for $67 each way. So for the most part, what I try to do is each day get to both of those places. So imagine paying $150 a day to take Uber because it's serverless and I pay for just what I use. Well, do that 20 days a month and you're dealing with $3,000. But a Mercedes payment's $1,000. So you can see how it might be much cheaper to buy the Mercedes, pay the gas, pay the auto. Not that you need to drive a Mercedes, but you get the point. So in some cases, Uber makes sense. You live in New York City and you walk everywhere and you just take something here to here. Uber's beautiful. You live where I live, where you're not on top of things. Uber's too expensive if you use it every day. So that's what you should think about this. What is your use pattern and what's it going to be? Now, Azure functions are great because they're just little mini snippets of code, does one thing and nothing else. So it's great for you to create things. It's great because they're simple and you need less people. So it gives you the ability to create a logic and pop it into various code functions and have them work. And you don't know, and you don't need to know anything about the underlying infrastructure. Now, is not knowing anything the way to actually create a good strategy? Probably not. But, and here's the big but, we don't always have the people that we need. And if you're a company that's got a whole lot of developers, this is the greatest thing in the world in a developer-based culture. So it's all based upon where you're at and the actual use case. So you can actually see in this particular case, let's say we had something where you had an API call and from an app, and that kicks off, say, an Azure function, and that stores some data into the Microsoft NoSQL Cosmos database. Sorry, can never remember to share my screen. It's hard to present and remember these sharing things at the same time. So in this case, you've got a web app that kicked off something. So that's going to send that to the Lambda function. I'm sorry, the Azure function. Lambda would be AWS. And that function does what it's supposed to, and it's got a little database to store or persist, so it sticks it in a NoSQL database, in this case Cosmos DB. And once it's stored there, well, something else has to happen, right? So then you've got another function to do its logic, and then maybe you fan that out and send a notification that the job's done. I don't know. Or you send a message to another application. That's realistically speaking what we're talking about. So that is the basis of functions. So we're going to get up to images. And actually, let me talk about images, and then we'll go see if we have any questions. So typically speaking, when we're dealing with a virtualized environment, we've got an image of our system, and I may show you what that looks like. Now, in the old days, we could make a bit-by-bit copy of a virtual machine using software like Semantic Ghost. There's lots of ways we can image a system. If you'll recall, when we talked about making snapshot backshots of your data and virtual machines, when we talked about block storage yesterday, it's going to take your thing and it's going to make it a single file, just that little tiny file, an image. And we can take that image and relaunch it as another virtual machine. So when you're dealing with a cloud provider, they're going to have images for you, an image to launch something. But you'll have two kinds of images you can understand. So let me show you. I'm going to go back to my VMware data center and show you something. So if you actually look at the storage on this computer and we go into the data store that I have, let's browse this data store. Notice you're going to see some virtual machines. You see that little file over here? That one file, that cindythecat.vmdk? That is the image of that virtual machine. I could take this file and drag it to any other system and it will run. So that's your traditional virtual machine image. When you're on the cloud and you want to launch a Linux system, you don't have to do what I did and create the number of CPU cores and DRAM and then install the operating system, which we started to do. You basically click a button and it automatically starts. And Linux is booted. It's a pre-installed version of Linux or a pre-installed version of Windows Server or whatever it is that you're using in the cloud provider. That's an image. Now, you may also build your own virtual machine on the cloud and take a snapshot of that drive. That too is an image. Or, you see that VMware virtual machine image that I showed you? What if I wanted to bring that to the cloud provider? I can bring that image to the cloud provider. Or, what if I needed some enhanced load balancer and reverse proxy capabilities? I might go to the Azure Marketplace and get an F5 load balancer. What if I need security? I'm not going to build a high availability, high security system using the cloud provider's native tools. They're WAF. I'm going to get an industrial grade firewall that's more adaptive in nature and next generation firewall like you would get from either a Checkpoint or a Palo Alto or a Fortinet or a Cisco. Well, I'm going to get an image of that. I'm going to get it from the Azure Marketplace, the Google Marketplace, the AWS Marketplace, and it's going to be a pre-built virtual machine in the form of an image that I just launched, and all of a sudden it works for me. So keep that in the back of your mind. That is an image. It's a way to basically copy a virtual machine and move it anywhere you need. All cloud providers have it. Amazon calls it an Amazon machine image. And with Amber images, we can get managed images that they created. We can make our own image, and we can have one image that can support upwards of 20 deployments at the same time. So why do we do this? Because if we can make a single file that has all of our stuff in an image, it becomes instant, easily for us to add a new machine, remove a virtual machine, or pretty much do anything that we want. So that's why we typically use these things. And the last thing I'm going to talk about is bootstrap automation for a virtual machine. So you see in cloud computing how we can add servers on demand with auto scaling. Well, we'll probably talk about it soon, but we can. Your server CPU is too busy. You set a policy when the CPU hits 80%, add an additional server. Great. So when the server comes up, is it going to have everything you want? So maybe you set up your server and you give it a little script. In Windows, it would be PowerShell. In Linux, it's typically a bash shell script that says, wait, boot up. When the system boots up, basically, what do you do with an Ubuntu system? You do a sudo apt-get update, and you might have that command to update the operating system. And then you might have a sudo apt install httpd or something like that to put a web server. So bootstrap automation is the way you take one of these cloud providers, virtual machines, give it a little mini script, and it'll install everything you need dynamically, so you don't have to be there and do it manually like we used to do. So that is Bootstrap automation. So before we get into pricing or anything like that, I think it's probably time to check and see if anybody had any questions on containers, container orchestration, what have you. So is it not a single point of failure if something goes wrong on the OS and every virtual machine has its own OS? Well, potentially, but not necessarily. So if we were to put all of our containers all on a single virtual machine, that would be a single point of failure, and it would never make sense. Never. But we might put our containers on multiple virtual machines. And by doing so, we're going to be good to go. So let's look at the way this actually works, Vijay. We're going to have our control plane for, for our virtual machines, or for our containers. So actually, let me do this. I'm going to draw this out for you because you asked a really great question. And I love the way you're thinking. So I want to make sure we really show you. So in this particular case, let's say we've got a Kubernetes control plane. Oops. Wow. Bear with me. So here's our control plane. And then we have, let's say we have it on 2 different virtual machines. 2 virtual machines is not enough, but let's say we're doing it. 2 virtual machines for right now. And let's say these virtual machines, because in order to make this happen and run right, let's say these virtual machines have 256 cores, and let's say they've got 6 terabytes of DRAM. And this is how you would create high availability across two different systems. Now, obviously, you could do it across cloud providers, which would give you greater cloud availability. So now you put 50% of your virtual machines here. And obviously, you would use more than 2, but I just want you to get the concept. So we put 50% of our containers on server 1. I'll put a and we're going to put the other 50% of these on server 2. Now, this system has 256 physical cores. Now, let's just call them logical cores. Each one of these has 256 logical cores. So what I'm going to do if I want high availability is I'm not going to use more than 50% of the capacity. So that means I'm not going to subscribe more than 128 cores and 3 terabytes of DRAM. I'll fix this. You can see it. And I'm going to do this on each one. Why am I going to do this on each one? Did you notice I have the ability to I'm only using half here. So now we got this Kubernetes cluster, and let's say we've got a container running. So we've got a container, but we need 10 of these container instances running. And because we've told Kubernetes we only need 10 of these container instances. As it stands right now, 5 are running here and 5 are running here. Everything's great because we're running on 2 different servers. Now, server 1 dies. Let's put a big mark through it. Server 1 died. So it's got this big, ugly thing. Now, how many container instances are we going to have running here? We needed 10. We're going to have 5 that are currently running on server 2. But Kubernetes knows that we need 10 of these things. So what Kubernetes will do, it will take the 5 that's running on server 2, and it will say auto scale 5, and it will add 5 to server number 2. And by the time it's done, we're going to have 10 containers running on server number 2. So that's typically why you would split it across multiple loads. Because if you put it all on one virtual machine, you are correct. It's a single point of failure. But one of the great things about Kubernetes, which is why we love it, is we can say, I need 100 of these containers. If we need more, it can scale out, auto scaling. We can do this in our data center if we've got capacity or cloud. If we need less scale in, one container crashes, it'll just start another one. So that's how you may hear about Kubernetes being self-healing, because that's architecturally what's going on under the hood. That was a really great question, so I wanted to make sure I answered it correctly. Can containers run, say, an application like Photoshop where it's used consistently? Or will it be just a function when it starts and competes? Both. So let's say you were to go make an OpenStack cloud. Every one of my students in our Cloud Architect program, even though Cloud Architects don't touch the technology, they build an OpenStack cloud. And why do I do it? Because after you've built the cloud and you understand the control plane and the data plane and all this stuff, it makes you better understand the technology. Now, when you build an OpenStack cloud, it's going to actually have a database of where all your stuff's running. It's actually going to be MongoDB, which is an open standard database that runs in a container. So we can have containers that run 24 hours a day, 7 days a week, 365 days a year. And a lot of our containers are going to be like that in cloud computing. Or we could run a temporary application. Now, there are some operating systems that are designed for extreme security. And by default, everything that you run, every application opens up in a new container. And that way, let's say you used your web browser. If it's containerized and then a hacker gets control of your web browser, they are isolated to your container and they can't find other forms of your operating system. So there's lots of these security-based Linux operating systems that you could use if you're super security concerned. And that will run them all in various containers. So it can do both. I think, Chris, we can go to the next one. Is there a Docker layer? Docker is the runtime module. So typically speaking, Docker is not used as a control plane. Docker's what you put on that server so it can understand how to run with the containers. Kubernetes is typically your control plane. And what you typically have is a Kubernetes control plane and the Docker sits on the server where it actually runs. Good question. Any more, Chris? So can you have multiple control planes? Well, you can have multiple control planes orchestrating different things if you wanted, or you can spread your control plane across multiple providers. It depends what your ultimate goals are. But yes, you could have multiple control planes. And when we think about technology, I'd like you to think about what's controlling the tech and what's doing the work. And what do I mean by that? Because everything in tech, or pretty much everything is life. You got a car, right? A modern car has a computer in it. The computer determines your fuel oxygen mixes that determines whether you're running in high performance or low performance. That's the control plane. We all have a brain in our head. If our brain doesn't work, we can't walk, because even though we have muscles and joints and bones, it's the brain that actually sends the signals to move. That's why if there's a problem with the brain, like after a stroke, somebody might lose one side of their body. If there's a problem on the spinal cord, which is where the brain goes and sends messages to the body, it can't work. So there's always going to be a control plane. When I was young and I used to deadlift 700 pounds, the brain was the thing that told my muscles to do the work. Muscles couldn't do it without the brain. So the data plane is always going to be there. Hope that kind of helps. These are good questions. All right. So before we go back, let's talk about three things. One is I want to make sure that if your goal is to become a cloud architect or a solutions architect or an AI architect, join us on one of our free webinars on Thursdays. We'll go over the role, what we do, all the skills you need, and it's free. You can ask questions. I just want to help you have a great career. In the description of this video, there are a tremendous number of free resources for the interview, resources for AI, resources for so many things, how to become an architect, what have you. Download them. They're all free. I want to do as much as we can. If you want to learn more about containers, we've got Kubernetes videos on our YouTube channel, Kubernetes blogs on our website. Want to learn about any of these things, chances are we've got a lot of things out there that are for you. So I'd love you to get access to it. So give us a like, or if you're having a good time, subscribe to the channel and hit the bell to be notified of new videos. And give me a hashtag AZ305 for the Azure Solutions Architect Expert Exam. And then I will get back to the content. Start to see them coming in. I know everybody's awake, alert, and oriented. All right, so now let's talk about how you pay for these virtual machines and what that actually really means. Realistically speaking, there's 3 ways you can pay for it. You can pay as you go, which is going to be the most expensive approach that I don't know what I'm going to need, so I'm going to pay for it as you go. In life, here's what that's like. It's like showing up for a concert the day before and buying the last ticket, or buying your airplane ticket the day before you've got to go on a flight to, say, Greece. You're going to miss out on buying it ahead of time in advance, and you're going to pay the most money. But you can still go to Greece, and lots of times we have to make an emergency flight. The next option, which we'll talk about, is reserved, and reserved's a little different. Here's reserved. I'm going to buy your stuff for the next 3 years. Give me a discount. That's reserved. And then spot, which we'll talk about, is there's unknown capacity left. I'm going to pay a price, and if nobody outbids me, I'm going to use it. So that's really what we're talking about, but we're going to get into a little more detail on that. But I wanted to summarize it. With the pay-as-you-go price, you have no commitments. You don't pay anything ahead of time, and you're billed per second. So if you don't know what you're going to use, this is beautiful. It's great. I have no idea what my capacity is. I'm either going to need 1,000 servers or 3 of them. Well, use pay as you go, because you don't want to purchase 1,000 servers if you only need 3 or 4. But when you figured it out, probably not the best thing. So where is this pay as you go going to be useful if you don't know? How about a website? So let's say I've got a global retailer and they sell stuff. I don't know. What are they going to sell? Sporting goods. Something I like, sporting goods. Okay. So we've got a retailer that sells sporting goods. Now, generally speaking, that retailer that sells sporting goods, they have their web servers sit at approximately 3% utilization all year long. And when the Christmas holidays come, those type of holiday season comes, all of a sudden, those servers get used to 98% of their capacity, and people buy. And the rest of the year, it's running at nothing. Well, in these environments, this is where that pay-as-you-go, auto-scale, use small stuff all year long, and then add what you need, and then shut it down when you don't. This is the time where cloud computing can save money. So when things that run 24 hours a day, 7 days a week at capacity, they're going to be a lot cheaper in the data center. Don't put that stuff in the cloud. But on a web server like this is much cheaper in the cloud because we build based upon what we need on average, and we can add capacity. And then that's where your pay-as-you-go pricing. Or you don't know, or it's a short-term workload. Now, here's where you would use reserved instances or reserved capacity. I know I need 100 virtual machines of this size. And I know I need those same 100 machines all day, every day for the next 3 years. Well, the cheapest option is probably stick those virtual machines in my data center. But what if I want to be in the cloud? What if I don't have the people that can run the data center or the sophistication and knowledge to run the data center? Well, stick them in the cloud. And by going to Microsoft or Google or AWS and saying, I'm going to purchase the stuff for the next 3 years from you, they're going to give you a discount. In some cases, it could be upwards of 50 to 70%. So that's going to be based upon you knowing what you need. So every time you see somebody that works out there for a cloud provider saying you don't need to know capacity planning, you just stick it on the cloud and it's going to work. Well, if you don't know capacity planning, you can't do this reserve thing, which means you're going to pay 3 to 10 times more than you need to. So you need to understand capacity planning because you need to analyze it. Same way a business would build a budget. That's what we're talking here, reserved instances. So on demand, added when needed, you don't know anything and you pay out the nose for them. Reserved, you make a commitment and the cloud providers can say, oh, well, Mike's going to use these servers. I'm now going to build more servers and I'm going to do so. You get the point. It gives them predictable revenue, and predictable revenue gives them the ability to invest in their business and make more profits. So they will give you a discount. Now, the next thing we have is what's called spot pricing. Spot pricing is a very unique situation. Spot pricing is basically you can purchase for a short period of time unused computing power from the cloud provider. So cloud providers got a million servers. They're only using 800,000 of the servers, and you want to use 1,000 of them. You just say, I'm going to pay you this amount of money to use the servers, and the cloud provider agrees. And then while you're using the system, the cloud provider gets busy, you get shut down. Or you agree to pay $50 per server, and somebody else says, I want the capacity and I'll pay $51 per server, you get shut down. So what does this mean? If it matters, don't use spot pricing. So when would you use it? Maybe you've got a stateless application that can start and stop 100 times and it doesn't matter. Maybe your application's so fault tolerant, it doesn't matter. Or maybe you've got a non-critically important batch job where you want to mine through a whole bunch of data. You need a whole lot of capacity. And if it doesn't work, you don't care. So your best pricing is typically going to be coming from a combination. When you don't know what to use pay as you go. When you do know what you're going to do, reserve it. And when you know you need to do a tech job where you need lots of computers and you don't care what happens, well, that's when you use spot pricing. So I had a friend that used to test routing code. And what he would do is he would go to the cloud providers and they would launch a Terraform script and they would launch like 10,000 virtual machines to throw data at this routing software to see what would happen. They use spot pricing because it would go up, down fast. And if the QA test failed, who cared? Because they were saving upwards of 90%. The QA person would test it again. So I don't have a lot of friends in QA. I respect those people in quality assurance for making sure things work, but that was a use case for this spot kind of pricing. So now, how do you secure your virtual machines? Well, a lot goes into security, and it's more than what we're going to talk about now. It's about boundary definition and policy. There's so much that goes into security. But how would you secure the virtual machine? Well, the first thing you're going to use is a network security group. And basically, that you can tell it, allow this into the virtual machine, but not this. Very firewall it. So if I've got a virtual machine that is a web server and it's only answering to HTTPS, my network security group should only allow traffic to HTTPS, which is TCP port 443. So that network security group is going to help me. No, let's be fair. It's not enough. Now, when that virtual machine comes up, they are not secure. If you guys look at a netstat on your computer and play with the various netstat switches, you'll see how many ports your computer is open and listening on. It's scary. It's terrifying. And why is that? Well, when you build a server or you release the operating system, you don't want to get a million tech support calls, do you? I mean, quite frankly, I don't. So you turn everything on so the user can just click a few buttons and everything works. Now, when you turn all this stuff on, everything that you turn on can be a vector to hack the system. So on your virtual machines, you'll use these network security groups. You'll disable these unnecessary services. You'll pop some host-based protection, some anti-malware, some host-based firewall, some host-based IDS, IPS stuff. You'll patch these systems. You'll leverage your identity and access management thing. Hopefully your systems are firewalled. There's a lot that you're going to do, but at least understand that's some of it. So if you're going to look here, you can see, let's say you've got you've got a subset of VMs. You could put these network security groups, and they're going to be attached to the network interface card or the virtual network card that's attached to this. And how do you configure an IP address for a network interface? Well, it's got to have an IP address, right? They're typically going to be assigned by DHCP, the Dynamic Host Configuration Protocol. And that's typically what we're dealing with. So we can have private IP addresses, which you're usually going to use for your things inside of your network, and anything that's going to need to be Anything that's going to need to be externally facing, meaning access from the internet, must have a public IP address. The exception is typically load balancers. We typically put the load balancer with a public IP address, and the web servers behind the load balancer are typically private address, because the load balancer will proxy or be the front that's seen to the internet. Now, we talked a lot about compute, talked about storage today. Now we need to get into databases. And Azure has a lot of database services. They have Azure databases. We have relational databases. We have MySQL databases. There's various databases we'll talk about. We'll talk about various services, like a database migration service. So there's a lot of stuff to talk about in databases. I'm going to introduce the database fairly quickly. We'll talk for about 15, 20 minutes. We'll take a break, answer some questions, and do more database stuff. So what really is a database? A database is really a way to take your data, store it in a secure environment that scales, that enables us to easily find our information when we want it. Here's the difference. Let's say, have you ever gone to somebody's house and they've got little rows and columns inside of their closets and everything's exactly where it's supposed to be? And when you need to find something, you just go here, boom, here, pull it out. I love this. This is not me. I've got shelves and racks that are full with stuff going all everywhere. And when I need to find something, even a pen or a pencil, it could be this thing. I got to pull stuff, move stuff, catch stuff, do this kind of stuff. Well, that's typically what file storage is. People just throw stuff in there and they can't figure it out. A database is designed as a system to logically store information and make it very easy for you to find it. And when we're dealing with this, so it's a type of application. When we're dealing with databases in Azure, many of them are fully managed, which means we don't have to worry about patching them, backing them up, monitoring, because so many of these are designed for us. So we're going to talk about some key features of Azure databases. Many of them are a managed service. What's that mean? It means it's all pre-made for us. We just push a button and the databases open up. They tend to scale. Typically speaking, they're high availability. We all have differences of what we consider high availability. Good databases we're talking about typically are secure. The Azure databases typically integrate easily with the Azure ecosystem, and they support multiple database engines like MySQL versus Oracle versus Postgres versus MariaDB. Lots of different vendors in the database space. So we'll first talk about relational databases, and I'm not a database person. I'm more of an infrastructure architect. But we all architects come from some background. A relational database stores data that is related to each other. What does that mean? Mike purchased something at a certain price. The price and what I purchased is related. And, a business can go back and look at that and say, well, Mike only buys stuff when it's 20% on sale. Maybe send him a 25% off coupon and he'll buy. So that's why businesses store this data that's related to each other. Not because they feel like storing it, because maybe they want a transaction log, or maybe they want to be able to infer or make a business decision based upon insights that they glean from their data. So there's that. So when we're dealing with Azure managed database, they're backing it up for you. They're patching it for things. They're provisioning it. So much of it is done for you, which maybe it's good, maybe it's not. Now, in this relational model, you can see that you've got a customer number, an order number, an amount, their contact information. All this stuff is related to each other. And relational databases are the most common form of database. And they provide storage and access to the data that's related to each other. Typically speaking, your data is going to be stored in columns and rows, just like a spreadsheet. In fact, Excel, some people would all call it a database, others would not, but it's kind of database-like. But basically speaking, each row is going to have its unique ID, which is going to be a key, and the columns in the database will hold the data, or will have these things called values. That's typically speaking what we're talking about with regards to databases. So that's really what we're talking about. Now, Azure's got this concept of an elastic pool, and that's where multiple databases can share resources inside of a pool and scale. So, lots of features related to the way Azure actually does these things. But know that these Azure databases are integrated to the Azure ecosystem. Things like Azure Data Factory or Power BI or Logic Apps. They tend to be fairly neatly integrated when you're dealing with Azure databases on Azure. Now, when you're dealing with one of these databases, there's automated backups. Typically speaking, it makes a backup image of your data. So if something happens, your database gets corrupted or deleted, you can bring it back. And you can configure your backup and retention policies. You'll also have some tools for monitoring your database, and you'll be able to look for performance bottlenecks, for example. And many things like tuning performance can be done fairly easily when you're there. So that's basically what we're talking about. So let's talk about which databases are here. At some point, we'll talk about how to scale these relational databases. And when we do the second week, we'll talk about best practices and Azure's recommendations. But we got to at least introduce the concept of database. So the first database we'll talk about is Azure Database for MySQL. What is it? It's the MySQL database that Azure runs for you. So MySQL database is one of the most common relational databases in the world. It's a freeware database, and you can use it on Azure. So it's fully managed. So you don't have to think about it. The backing, the patching, it's done for you. So reduced overhead. MySQL is compatible with MySQL, which is quite nice. And MySQL is typically compatible with a lot of other databases. Azure supports the community edition of MySQL, the enterprise edition of MySQL. There's some built-in high availability when you're using the cloud providers' natural databases, which are managed. And what are we really talking about? So the way it happens is these databases provide failover to another database that's sitting in, typically speaking, another data center. So as long as your cloud provider is up, you're going to be fine. Now that begs the question, should you use any of these cloud provider databases or manage your own database and stick it in 3 clouds? That's another story. But if you're using these managed, there's a simplicity and an elegance that comes with it. The cost is it's managed for you, and that may make life more complicated. Azure database for MySQL allows the compute resources to be independently scaled for the most part. And when we talk about how to scale these databases, we'll talk about read replicas, caching, queuing, that sort of thing. Because I want you guys to understand it. Because, for pretty much any career, you need to know something about databases. Now, when you're getting a cloud provider's managed database, it's going to come with an SLA or a service level agreement. Here's what a service level agreement is. We guarantee to have this, and if not, we'll refund some of the money that you've paid for the service. So most people mistake what's what I'm looking for? A service level agreement for safety and security. Let's say I put all my systems in a single cloud, and it's for a hospital. The single cloud fails, somebody dies because the doctors and nurses can't get access to the information because their electronic health records are on a single cloud, and it died. The patient dies, which means the family lost the patient. The hospital that is then sued from the patient's family, and they lose millions of dollars. But guess what? The service level agreement reimbursed you for your compute expenses that day. I mean, so I don't necessarily call it an equal trade. All the service level agreement is we guarantee to give you this, and if not, we'll give you a rebate on some of what you spend on our services. So kind of keep that in the back of your mind. I think we're going to go here. I'll take some questions for a few minutes, and I'll get into other database type stuff. What is the difference between a stateful and a stateless system? Well, we'll talk much more about stateful when we get to firewalls, but stateful means everything is being kept track of. This thing's over here, this thing's over here, this thing's over here, this thing's over here, this thing's stateful. Stateless is stuff's just happening and we're not paying attention to it. So state always means pay attention. The I'm watching you kind of thing, that's how I like to think of stateful. And actually, you know what, while we're at it, to kind of explain the difference, I'm actually going to use a firewall, because while we're talking about applications, this concept I have always found is the easiest way to explain stateful versus stateless. So let's say we've got a firewall here. Draw it up. Here's my firewall. Behind the firewall, let me do this. Let me get us a user that's going to be going to a website. Bear with me a second. I got a user in mind. Let me just bear with me so I can send this to my computer. Some of you already know who my computer user is going to be if you know me really well. But let's just, here we go. Okay, so we've got a computer user. Wow, I didn't mean to make her this size. Bear with me. So we've got this computer user. And she is connected to the internet. Firewalls behind the internet. And over here, you've got a website. World's best tuna and shrimp.com. Because this cat loves her shrimp and she loves her tuna. I mean, she's kind of obsessed with it, but that's neither here nor there. We love her. So if she were to go to an internet, and this will show you stateful, and this is the way firewalls work. Cindy goes to the internet, and on the way to World's Best Tuna, her traffic goes through the firewall, through the internet to World's Best Tuna. When she goes to the firewall keeps track, and it says Cindy going to, and let's come up with this ridiculous name that I made up at the time. Hopefully I'm not using somebody else's website. And if I am, they're getting free advertising. So be it. They're probably happy. So Cindy is going to world's greatest tunaandshrimp.com. The firewall keeps track of this, which is called state, goes to world's greatest tuna.com. Now, world's greatest tuna.com, the website responds, it goes through the internet, hits the firewall, and the firewall says, well, yes, Cindy was going to world's greatest tuna.com, so let her traffic come back, because the firewall kept state. Now, how is this very different? Now, over here on the outside, we've got a bad actor. We've got a bad cat. And the bad cat's trying to come into Cindy, and it hits the firewall, and it's black. So the bad cat can't get to Cindy. Now, if Cindy did not request information from world's greatest tunaandshrimp.com, and they send information to Cindy, it's still blocked. So state is really related to just keeping track of everything that's actually going on, and by doing so, doing some action based upon it. I hope that helps. Let me go find where For an architect job interview perspective, how deep should we know about DBMS and RBS systems or any other database? Well, Vijay, let's talk about the difference between architecture and engineering. In engineering, I'm going to ask you about various tables and other deep stuff inside of it. In an architect, I might say to you, an airline is experiencing extremely high fuel costs. What could you design for that airline to reduce their fuel costs? That's an architect question. Where at this point, I'm expecting you to be able to understand the technology, to be able to figure out what kind of databases you need at a high level, whether you can do some machine learning on those databases, what price prediction fuel strategies could you use, what kind of data do you actually need, how are you going to smooth that data, how are you going to manipulate it. That's an architect. And that's why, Vijay, these exams that cover architecture have nothing to actually do with architecture. How would you design your demilitarized zone for a mission-critical web app for a bank? That's an art question. Another architect question might be on an interview that an organization has 6% weighted average cost of capital. How would you leverage that information necessary so you can make the calculations to determine whether you should get a private cloud or a public cloud? Or an architect question might be, an organization currently has these business processes. They'd like to tune these business processes based upon what AI could do. What recommendations would you make on the people, the processes, and technology? That's architecture work. So, as an architect, what do you need to know? Well, you need to understand the difference between the various forms of databases. You need to understand how to make those databases scale. What kind of technology would be necessary and drive necessary in speed and performance to make it scale? Why would you use the right kind of database? But we're not engineers. We're not going to be looking at code. We're not going to be getting into the nitty gritty. I like the way my friend David Lithicum said, if I interviewed somebody and they could tell me the idiosyncrasies of a cloud provider's APIs, I wouldn't hire them as an architect. They'd be an engineer. So we're really talking about that. So kind of keep that in the back of your mind. That's kind of, it's kind of different. You will need to know databases, but architecture is not what you're thinking it is. And that's why all these people get 1,000,001 certifications. They learn Python, they learn SysOps, they learn DevOps. And then someone gives them an architecture question and they're like, huh? So VJ, please join us in the free webinar. We'll go over the whole role of everything you need to learn because I truly, truly, truly want you to be highly successful. Do the various parts of Microsoft Fabric like Power BI run on Azure? They can run on Azure. They can run on other places. They don't really tell you where they run all these things, but you can definitely run them on Azure. You could also run them on other infrastructure. How do you securely connect those managed databases to your virtual network to prevent applications from other users in the cloud? Some databases have a public IP. So generally speaking, your databases are not going to have a public IP. And I wish I could actually teach you this, but that's the kind of thing we do in our Cloud Architect program. And why do I say our Cloud Architect program? Because it's a 900-hour program. And it takes a lot of complexities because we need to talk about the network. We need to discuss network security. We need to discuss network segmentation points and kind of keep that in the back of your mind. And do we have training on architecting Spark solutions? So let me explain architecture. We are not engineers. There is no architecture on Spark solutions. Spark is a big data framework. PySpark, Apache Spark, there's lots of big data framework. Architecture would involve how do we create a data strategy? How do we manipulate that data strategy? How do we normalize that data? How do we create data hygiene? How do we learn from that data? And what can we do with that data for business? What you do with Spark itself is engineering. It has nothing to do with architecture. Architecture is more about solving business problems, and it involves people, processes, and technology. Architecting Spark solutions would be a Spark engineer's job. They wouldn't be architecting, they'd be kind of building and kind of doing that deep, hardcore system design. And when we go, if you join our webinar, we'll talk about how we architects have to build a team. And I'm doing a cloud architecture. I'm going to need a I don't know. So if I'm going to build an architecture, I'm going to need engineers and architects with me, usually 15 to 50 people. Why do job descriptions have everything under the sun? And well, let's be fair. I've never seen an honest job description in my entire life. I don't value job descriptions. I don't care at all what a job description says. And I've never been on an interview where I've not been hired or given a better job. So here's what I do when it comes to job descriptions. I completely disregard them. I work with good recruiters. I teach my students how to build recruiters, and I make people come to me. I interview with the hiring manager. The hiring manager says yes. Then I apply for the job. Then I interview for the job. I'm sorry. So I go to the recruiter. They send me to the hiring manager. The hiring manager says the decision to hire me. Then they make me apply for the job. Then I start my job. I work in my job. I get promoted, and then I get auto rejected from HR based upon a bogus job description. So There's a really good job description for which is out there. It's published in CIO Magazine for architects. So join us on the Thursday webinar. You can also look at the CIO Magazine definition. We'll give it to you on there where you can actually see what hiring manager is saying. But I've never seen a job description that actually ever mattered in my entire life. And quite frankly, I've never been on an interview where I didn't get hired. You got a back door when you're going to these things. You've got to go to the hiring manager first and their strategy, which we talk about. We'll talk about some of that on the webinar on Thursday. And you can ask questions about it. But no, don't assume any job description is ever going to be anything close to accurate. Okay, let's get back to some content. So the next database we're going to talk about, which you can use on, on Azure, is Postgres. Now, Postgres is another open source database, means it's free. But with Azure, it's going to be a fully managed relational database. So all that backup, patching, monitoring stuff is done for you. Postgres is a very scalable database. While it is a relational database with those rows and columns, it scales so well that many organizations use it as a data warehouse. What's a data warehouse? It's a giant database. You stick all your stuff inside of there. And when it comes inside of the database, you can pull your information out. Businesses use it to get what's called business intelligence, meaning if you've got all this data in your database, you can look back. Pricing strategies, customer strategies, maybe a certain subset of your population likes a certain set of things, like maybe people like me that are from Greece buy extraordinarily large amounts of olive oil. So if you find that Greek people like me buy a lot of olive oil, send a lot of olive oil to us, or what have you. So you've got access to the Community Edition and the Enterprise Edition on Azure. It's got automatic backups on Azure to give you point-in-time copies. Again, these are high availability because they've got automatic failover built in because they're managed databases with geo-replication options to make sure that your systems are in some other part of the cloud, as long as the cloud's there. We can create read replicas, which we'll show you and talk about soon. So we can also run MariaDB. And maybe one day, MariaDB is another option. I'm pretty sure it was built by the same people that made MySQL database. Again, it's a managed service, which means they're going to back up, patch, do what have you. And by using the managed service, it's simpler for you. MariaDB is a fairly compatible database. It offers support for JSON, GIS, and various forms of temporal data. And it's typically very compatible with MySQL, which is the most common relational database out there. And the reason is it's free and it's compatible with MySQL because the people that made MySQL made MariaDB, giving it extra features, functionality, and scalability. So automatic patching, automated backup, automated monitoring. Now, we also have SQL Serverless. And that is an Azure SQL database that you don't have, that does not sit on a virtual machine that you know about. It sits on one of their servers, and it's designed to give you relatively decent price performance. And this is for people that don't want to manage servers. If you don't know what to do, this serverless stuff is great. If you do know what to do, serverless stuff may not be great. Here's the way I like to think of servers. Let's say I wanted to make a hamburger. Serverless is like going to McDonald's and asking for your hamburger. Every single time you're going to get the same hamburger and it's going to be based for perfect people. What's great about it? I know what I'm going to get. I can go to any McDonald's inside of the US, Canada, for the most part, get the same thing. Now, by comparison, what if I wanted a healthy hamburger made out of good beef because I could appreciate good beef? And I went into Morton's or Smith & Walensky or the Capitol Grill, and they had a grade of prime beef, and they ground it over there. And I said, I would like the center medium well, a medium rare. I would like this amount of salt, this amount of pepper, this amount of oregano, and this little amount of garlic in there. And they made me this custom hamburger, and I loved it. Well, that's really what we're talking about. Serverless is like the McDonald's. You don't have to think about anything. You have no control, no decisions what to do. You manage it yourself. You can do anything you want, but you got to know what you're doing. So what's the use case for the business? When we use serverless, SQL Serverless, it completely scales. So we don't have to think about it. It's going to add capacity when we need it, shrink when we don't need it, add memory when we don't need it, reduce the memory, and it's going to be based upon usage. It'll pause the database when you're not really using it, so you pay less. And as soon as you need it, it's going to restart. Nope. Restart. Stop. Restart. That's going to add a little bit of latency. Not a lot. It's like your car when you sit at a red light and the engine shuts off, and then you want to go and it restarts your engine. It's a little bit of latency. Now, does it matter? I don't know. What are you dealing with? So it's the same kind of thing. And if the database is paused, the first time somebody runs a query, it's going to result in an error until it comes back online. Do you want that? I don't know. But understand that it can reduce the cost. So you're billing based upon the amount of compute used per second. You pay less when it's paused, but you're still paying for the storage. With serverless, you don't have to know a lot. So it's very simplified management. Resources are managed. You don't have to manually think about scaling up and down. You've got good, very built-in performance tuning. It's kind of like doing it for you. It's flexible, supports all kinds of scenarios. Now, think about this. If it does more of it, I don't need as strong and capable of database people. So maybe I can get a database person that knows just enough to get by. Maybe they can help out with a little Linux and Windows along the way. So the people that are going to be using this are the people that are going to be hiring the jack of all trades that are not good at anything, not great at anything, but almost good enough to do the job. These are the kind of people that typically like serverless. Why? They don't need a lot of sophistication in their people, so they may pay much more for the serverless for the convenience and pay less on their staffing. Good, bad, and different. It all depends on what your needs are. So serverless could be great for development and testing. It's great, typically speaking, for infrequently used applications. Maybe a seasonal reporting tool. Maybe you're doing a proof of concept, because remember, it's going to shut down when you're not using it that much. And you have very little control. Now, you can set minimum and maximum virtual core limits. You can monitor your usage patterns, and you can potentially tune it to a degree. So that's your Azure SQL data serverless. It can integrate with ERP and CRM systems sometimes. So kind of think about that in the back of your mind. Sometimes people will like to go from a legacy database, meaning a virtual machine in the cloud, move it to the cloud. So this is one of those kind of concepts you could do. So now let's talk about Azure SQL Managed Instance. And what's that? It's another fully managed database service that's provided by Microsoft. It's going to be a cloud-based version of SQL Server. And that's going to be managed. So it's going to be pretty easy to migrate into your various cloud things. It's going to be fully compatible with SQL. And it's going to be a completely managed environment. Automated patching, automated backups, high availability. It's going to scale because they auto scale it for you. Scale up, scale down, what you need. And with the Azure Managed Instance, what you can do is you can get various performance tiers. General performance, business critical, and that way you get various underlying technology that's theoretically better for you and hopefully less oversubscribed and more available. Now, when we use Azure SQL Managed Instance, it does it gives you the ability to have transparent data encryption. It gives you some form of threat detection. It's going to look for threats and potentially respond for them. The transparent data encryption is I request the information from the database. It's sent to me. I can view it. When I send it back, it gets sent back encrypted. So it's going to be stored encrypted, unencrypted when it's sent to me, re-encrypted when it's sent back. So that sort of thing is transparent. It's being encrypted to you, back from you, and phrase. So it's always going to be encrypted, but you're not going to know about the encryption. Azure SQL Managed Instance works via hybrid clouds because it's a SQL server. And if you've got IP connectivity through it, through a VPN or a private line like an express route, you'll be in good shape. Because it is Microsoft managed, it's going to support Active Directory and Entrada ID for authentication of your users. Makes it pretty easy to take your existing SQL Server applications to the cloud without really changing your code, because it's the same thing. It's just managed for you. And you can use what's called the Azure Database Migration Service. What's a database migration service? It looks at your data. It's going to look at how your data is structured, and it's going to take it and it's going to manipulate your data, so it's going to be in the optimal format for the most part for your data in the cloud. Azure Instance is, again, Azure SQL Managed Instance is pay as you go. And you've got the option to include your SQL Server licensing inside of your subscription. These things tend to get reduce administrative overhead, so that can improve operational efficiency on your team. You can manage this database via the Azure portal, the CLI, or PowerShell. It meets various compliance industry standards, and your data it's protected in transit back and forth to your users and at rest. So because it's doing that encryption, decryption on the fly, encryption on the way to you, on the way back, that kind of thing. So where the other one was completely serverless, more dev test environments, this managed and infrequently used, this Azure SQL Managed Instance is designed for enterprise applications, where you've got legacy systems that you decide to modernize, or hybrid clouds, and it typically is high availability. Now that's relational databases. And at some point, we'll talk about how to scale these as well. But let's talk about the NoSQL databases, are not only SQL. So traditional databases are rows and columns. They're great for structured data. Cindy the cat bought 50 bags of Bonkers Per Pups at $1.99 per bag of 4 lollipops. And yes, we buy 50 lollipops every 3 weeks for her, because if we run out of lollipops, my cat's not going to be the happiest camper. And she likes them. That is structured data. But what if we have unstructured data? What if we have a different kind of data? What if we need unlimited scalability? Well, that brings us into the world of NoSQL databases. Now, relational databases are 30, 40 years old, maybe 50. NoSQL databases were designed by IBM in the 1970s, so they're not exactly new and exciting. But NoSQL databases scale really, really well. They've got extraordinarily good performance, and they're very flexible. So they tend to scale very, very well. And realistically speaking, we can do what's called horizontal scaling in many cases by adding capacity. So for example, Apache Cassandra is a NoSQL database. It will write to all nodes. So instead of buying these big massive servers and a few read replicas like we would in a relational database, with the Apache Cassandra, we can just get a whole bunch of these nodes and use cheap commodity servers. And that is a NoSQL database. And the cloud providers love to use this term elastic scaling. It'll adjust up and down based upon what you need. NoSQL databases are generally low latency, high throughput, big environment. They're flexible. So instead of storing Mike buys Bonkers Per Pups at $1.99, we can see that Mike, for example, let's say I wanted to go to Netflix and I wanted to watch a video and I wanted to stop it at a certain place in the video. Let's say I'm in the middle of John Wick. And while I'm watching John Wick, my wife says, dear, could you do this for me? I pause that video, and then it writes to a NoSQL database that says Mike is 1 hour, 29 minutes, and 15 seconds in there, so it can store the state. Typical NoSQL kind of environment. I've got video game players. I don't know what video games people play. I don't play any of them. I wish I did, but I don't. Never got into it, or not in decades. But you stop in the video game and you restart it. That's not structured data. That's flexible data. That's the kind of thing that goes here. If I were to make an Instagram post and all of a sudden I'm in an Instagram post, where is that information stored? Typically speaking, in a NoSQL database. So relational databases, things that are highly structured. Databases are things that are not structured. So I kind of hope that helps. Or NoSQL are typically. With our NoSQL databases, if you're in the cloud, Azure, their managed databases will work across regions. And if you're across various availability zones and regions, the only thing that's going to take your database down is a hacking event. We see it happen all the time. A control plane failure typically doesn't happen. Or a networking problem, we see that happening all the time. So you might want to put your databases in 2 or more clouds as opposed to more than one availability zone, which means data center and region. But, it's up to you. It's up to the business that you're dealing with and their needs and the complexity they're willing to deal with. So when would we use one of these NoSQL databases? Well, imagine you got airplanes flying through the sky and they're all beaconing stuff. That's a great use case for an IoT application. Video games, social media applications, content management systems. Very big data. Let's talk a little bit about the Azure Synapse Analytics. Now, Azure Synapse Analytics, it used to be known as SQL Data Warehouse, is a data analytics service. And it's really designed so that people can analyze data, look at data, integrate big data into their environment. So it enables us to integrate data and pull data from various pipelines. And there's about 90 built-in connectors we could use. It's serverless, so we don't have to think about the underlying infrastructure. We may be using it to analyze certain information that could be coming out of various databases and things. So you can think of it as big data analytics. It's typically got some form of Apache Spark integration. You could use it to start querying data in data lakes, for example. It gives you the ability to run some on-demand SQL querying. And the such. You might be using this to start working with machine learning, where you're going to build and deploy and train models within Synapse. Predictive analytics. Basically, you're going to use this to look at all this data that's coming in and basically figure out, can you make business decisions in real time or closer to real time to assist that business to do something better. So we might use it, and these are typically big data analytics environments. Now, Cosmos DB. There are a lot of wonderful NoSQL databases we can use. For example, we can use MongoDB across all clouds. We can use Apache Cassandra across all clouds. And the cloud providers make their own proprietary databases. Now, let's be fair. They're great databases, whether you're dealing with AWS's DynamoDB, Microsoft's Cosmos DB, Google's Cloud Bigtable. It is a fully managed NoSQL database that's designed by the cloud provider. Here's the problem. 98% of organizations are multi-cloud. So how on earth are you going to run Azure Cosmos DB when in AWS and Azure when you've got a cloud going on AWS? You're not. So if you're multi-cloud, you can't use these kind of Cosmos DB databases. You have to use a Mongo or an Apache Cassandra. So anytime we talk about one of these cloud proprietary features, I'm going to tell you about where the weakness is. That's the weakness here. If you just were going to be in Azure and you were one of those 2% of the enterprises that could do that, and Azure's a great cloud, you could use this fully managed Cosmos DB, which is a fully managed NoSQL database. It has single millisecond response times. That's not great. It's not terrible. It scales great. It's got good enterprise grade security. Of course, it's been hacked several times. and users' data, but you can't stop being hacked. You can try your best to prevent it. But if you're Amazon or you're Google or you're Cisco, you're going to have governments and states that are going to be trying to hack you at all times. Why? You're the highest value target in the world. Get into AWS, get into half of the internet. Get into Microsoft, get into half of the internet. So there's a lot to be win. There's a big reward to hack into these systems. So people are constantly trying, and that's why Azure's Cosmos DB has been hacked. Not because it's not good, not because they don't have good security. Cosmos DB, they say, is 99.99% available. That means 52 minutes of downtime per year. It is completely serverless, which means you don't have to think of the compute and the storage infrastructure. It stores everything on SSD storage, which gives you lower latency. It's a multi-model database. It's schema agnostic, so it can be very flexible. And it's got multi-API and multi-language support. I love anything that's multi-language because we speak multiple languages in my home. So where would you use Cosmos DB? Any place where you would use a NoSQL database. E-commerce platforms, gaming leaderboards, web and mobile applications, social media applications, that sort of thing. We'll briefly talk about Azure Table Storage. And Azure Table Storage is really a NoSQL database itself, designed to be massively scalable and provide a high availability storable storage solution. It's for applications that require flexible schemas, web applications, IoT. And with that, there are web applications. So the next phase that we're going to deal with is going to be how do we scale a relational database? And that's a pretty good topic that I think any architect needs to understand. So I may save that for tomorrow. So let's see if anybody has any questions for today. Because it's 4:46, I can take 10 to 15 minutes of questions, do anything I can to help you before the end of the day, and we'll come back and have lots of fun tomorrow. I'm always excited to go and teach tech. What's the difference between encrypting databases and encrypting blobs or S3? How do you connect your VNet with a public service? So let me try and explain. So here's the difference. For the most part, if you're going to have a database and you're going to put it on a virtual machine, you're going to encrypt that entire block storage volume. If you were here yesterday, you recalled that virtual machines can't post to object storage. They have to store things on block storage. So we can encrypt the entire object storage bucket like S3 or blob in much the same way we can encrypt the drive. But, and here's the big but, with some of these databases, we can do what's called transparent data encryption, which means it's going to encrypt it on the way to you, encrypt it on the way back, and encrypt it stored. That is going to be different than the way these things work. Now, typically, how do you access these public services like S3 or blog? Well, typically speaking, in your environment, whether you be your VNet or your VPC, you'll typically be able to create an endpoint of some kind. For example, in AWS, you've got a gateway endpoint for DynamoDB and S3, or an interface endpoint. So whenever we're dealing with these public services that are outside of your VNet or VPC, there's typically speaking an endpoint of some kind that we're actually using. And that's how we're using the provider's network to create a secure environment, almost like a virtual wire on their network that's actually going to be tunneled over their IP network. So you had two really good questions in there. You don't have to be shy. I'm happy to answer a few more questions if you desire. Was that clear? If you guys have questions, guys, I mean women, men, anywhere. I don't care. I just use the term guys a lot. So any other questions? Well, let's do this. even though I'd love you to do some hands-on labs, so make sure you get a copy of the Azure lab demonstrations. I really think they will help you, especially if you're a hands-on person like an admin or an engineer, really get it. And if not, at least I know me. I like to periodically get my hands dirty to little play with something just to see what others do. So it's that. Would you advise interviewing for your first architect position with your current employer, or is it best to apply with an entirely new organization for your first architect role? So that is a good question. And a lot of it's going to be based upon what your current employer knows you for. So I'll give you an example. I was working as an organization. I always worked as an architect, and I loved this company. It was the best company I ever worked for, but I took a job there as a sales engineer. A sales engineer, technical solution architect, they're a lot more alike than these bigger cloud architect roles or enterprise architect roles. In that you're not really touching the technology, you're designing, presenting, and selling it. And I wanted to move into one of the big architect roles. And I spoke to my manager and said, I see there's some enterprise architect roles, those executive architect roles, and I'd really like one. And my manager says, you feel a little bit on the techie side to me. And I said, what do you mean? He said, well, you're not discussing enough about business. You're not discussing enough about people, processes, and technology. You give a good presentation, but it needs a little more of that je ne sais quoi, gravitas. You look, walk, and talk like you're still a technical solutions architect or a technical architect, more of an engineer than a full architect. And I said, okay. And I said, how would you feel about my MBA? And my manager was like, well, that sounds like a really good idea. I love this company. I wouldn't have done this. And I said, how would you feel about me going to sales training and leadership training and presentation training, all the things that I want? And my manager said, well, this is kind of good. Yeah, I like this plan. And then what I did is and I'm not joking. My wife can actually remember this. I went home to my wife and I said, I have to look, walk, and talk like an architect. So I bought some better suits. I'd go to meetings, and when they go to a meeting, I'd pretend not to know the technology very well. And I would bring in one of the engineers to do it, and I would lead the group and give the presentations. And after about a year of acting like I didn't know anything about engineering, and I knew all about people, processes, and technologies, and I started throwing my business acumen and my leadership realm, they started to see me as that executive, and my next job was basically a 6-figure raise as an executive architect. So kind of keep that in the back of your mind. I did that. Now, having said that, if I worked at the company and they weren't going to see me or give me the option, I'd go to another company. So it all depends on how the company sees you. In most cases, if you've got a real techie, like a really good engineer, they're going to have a hard time with their company becoming an architect because they're going to be seen as the techie, that engineer, and not the architect. And they're going to have to go somewhere else. So I would say, ask your company, feel them out. I'd like to do this. What are your suggestions? Okay, you want me to take this executive role, this executive role, this executive role? Fine. What else would you like me to do, Mr. or Mrs. Hiring Manager? And if they're not giving you what you want, start applying other companies. So it's really going to be how they see you and how they view you. Sometimes you get what's called typecast. And what that means is you've been doing something for so long, that's all they see you. So say like Arnold Schwarzenegger or Sylvester Stallone, all they ever made was action movies for the most part. Nobody's going to ask them to make romantic comedies. They're action stars. Likewise, Jennifer Aniston mostly does romantic comedies, that kind of thing, and people are not going to ask her to be in the next Terminator or the next Rambo. So it depends is the answer. It depends how people see you. I might ask people that I trust to give me what I call a 360 review. I would ask my peers to see how they view me. I'd ask my manager to see how they view me. And I'd really look into that. But it really depends. It depends on your past job. Are they going to see you? It depends the kind of company. Do they value training? So the answer is I don't know. But it's going to be based. But you could try with your current company. And if they don't see it, act like you're still happy. Be thrilled. Do everything. keep your management happy, and then go apply elsewhere. And that's what I would do. And I've done that too and recommended that after I've understood the situation. What about customer master keys for encryption? When do you use those SSECMK? So there's lots of ways you can manage keys. In some highly security environments, you might actually have your own key management systems. But customer master keys are typically used for encryption when you want more control over your encryption keys. So like that SSE-CMK is more server-side encryption with your customer managed keys. You typically would use it for very sensitive data, things that are regulatory, like healthcare type data, or proprietary information about maybe you've got a secret formula, for example, or a secret process. And that way you can use this to really rotate your keys and policies pretty easily. Great question there. All right. Well, John, we are more than happy to provide this training free of charge. For the most part, what we really like to do at Go Cloud Careers is share as much knowledge as we can. In our paid programs, we really focus on how do we make massive changes to people's careers for pretty much our cost. I was very lucky. I had the best architecture career you can possibly imagine, and it left me financially secure. So we love helping others. I remember what I did when I broke into tech and how much it cost me and how much we had to do to pay back those loans. And I don't want anybody to be there and have to do that. So we love providing training. We provide as much tech training as we can for free. Our paid programs are really full careers, like how do you become an architect or how do you do this? But they're big. But I really love doing these things and we'll keep doing them. We have lots more free training coming. And thank you so much, Valerie. I really appreciate that. VJ, you're more than welcome. And I'm so thankful to be here with you today. All right, maybe we finished 3 minutes early. So maybe if you can give the video a like, if you're not a subscriber, subscribe, and please hit the bell if you haven't. We got a lot of good things coming down the road, and I'd love to share as much of it as I possibly can with you. Tomorrow we got lots of fun. So join us tomorrow and have a wonderful day, everyone. Take care, everyone.